everyone. Hi. It's so good to see you. It's so good to see some of you. We haven't seen you for a long time physically. We have met before. We've seen many people that we have met during the project that have helped us evolve our solutions. So welcome to the Oceanwise final meeting. For those of you who are here in Lisbon, thanks for coming. I hope you had a great lunch. We were serving fish stuff in a very sustainable way. Hopefully it arrived in beautiful EPS fish boxes, all very fresh. Well, we are, for those of you online, welcome. Thank you for being here. Thank you for giving us your time. We are today here in Lisbon in a place which is a temple of culture. It's kind of an embassy that brings together African music and culture with Portuguese. It's a 27-year project that has been putting together our cultures. And I just wanted to remind you that when we started the project back in 2018, we were also in another temple. We started the project in a 17th century convent, the Convento dos Cardais here in Lisbon. And the main idea is that when we get together and we have to sit somewhere to talk between ourselves, we try to help projects that deserve to be helped and that need that. So a big thank to the Beleza Club, which is hosting us today. And I would first of all start. We have a message, a welcoming message from the Portuguese Secretary of State of the Sea. It's a short video, and we will start with that. But first of all, when we're thanking you for being here and online, we're thanking in the name of all the project partners, which is a great team that puts together 5 countries from the Atlantic Arch. That's Portugal, Spain, France, Ireland, and the UK. And I think I need to pass the slide. Yeah. No, okay, we'll have that slide afterwards. Well.
Dear friends, you are very welcome to Portugal. I'm pleased to be with you in this final event of the Oceanwise project. It is common knowledge that the oceans face today huge and global problems, such as climate change, loss of biodiversity, and pollution. And the Oceanwise project was created to address ocean pollution problem. To solve the marine litters issues implies to prevent the release of the litter to the environment. We must look for the solutions to improve the management of the plastic products by promoting a more sustainable use or by improving their end of life through more circular economy or invest in the new and alternative solutions. This was the focus of the Oceanwise project, which is aligned with the resolution for a global instruments for a marine litter adopted by the United Nations Environment Assembly in February this year. One of the strongest aspects of the Oceanwise project was the focus of the single type of plastics, the polystyrene, allowing people that work in this project a very much focused action and in-depth research with the purpose to present solutions to these problems. I am very proud to say that Portugal implemented a national decree of law that established as a mandatory that all fishing ports must have dedicated structure to densify and compact fish boxes made by polystyrene before they are collected for recycling. This was a direct and a very important result from the Oceanwise project. Finally, Portugal's vision for the sea involves a clear understanding that the ocean problems have to be addressed holistically, and the development of sustainable blue economy demands the protection of marine resources, a sustainable production, and equitable prosperity. I wish you an excellent meeting and a fruitful discussions. Thank you.
So, first of all, I want to introduce you to the project team of Oceanwise. So, as I was saying, so we have partners from, well, I think I'm going to start from where we are. In Portugal, we have DGRM, which is Director General for Marine Resources, which is a public entity linked to the Ministry of the Sea and Economy. Then we also have Universidade Nova, and we have Sociedade Ponte Verde. Then in Spain, we have two partners, Foundation Setmar, working closely with the fishing industry and sustainability. We have Sustain, which is a company, a new company working on circular economy. Then in France, we have three partners: CEDRE, which is a center working in marine pollution. UBS is the University of Bretagne Sud. And we have Seabird, EC Seabird, which is a small spin-off from University of Bretagne Sud, working on new plastic solutions. Then in Ireland, we have DHL-GH, which is a similar organization to the similar department to the Portuguese DGRM. So it's again the Department of State that's working in marine environment. Then we have REPAC, which is the partner working in it's a sister company to Sociedade Ponte Verde, so working on the recycling with the recycling. How do we say this? Recycling. Yes, exactly. And we have BIM, which does BIM, which does research also linked to the marine environment. And we have UCC Moray, which is the University of Cork, again, very close department working in the close to marine environment. Then in the UK, we have CIFAS, which is again doing research on marine environment and working a lot with the British government. And as associated partner, we have OSPAR, which is anyway where we started this project. OSPAR Commission deals with the pollution at all the Atlantic Arch, and it's where contracting parties, so all the countries in the Atlantic, we are part of it, and it's where we discuss a lot of the marine environment resolutions. So, as I said, Oceanwise started in as a reply to one of the items that was included in the Marine Litter Regional Action Plan. This is an action plan for fighting marine pollution that was started in 2014 at OSPAR. It had around 32 actions to be developed in several areas. Linked to marine litter, and one of them was how to reduce the impact of foamed plastics like expanded polystyrene and extruded polystyrene in the sea. We have seen that this presence in the sea, and we had a challenge. We had the challenge of how to fight this. We have been, when we started, some of you stakeholders told us, why are you focusing on EPS? And we said, well, we're focusing on EPS because as a group, within OSPAR, we're concentrating on a lot of issues. One of them is this one, and we decided it does need dedicated approach, and that's what we did for the project. And so we devised this project that basically what we did was to gather a knowledge hub on everything that had to do with foamed plastics, like expanded polystyrene and extruded polystyrene. We looked at its presence in the environment. We looked about what it does in the environment, how it affects the environment. We looked at the industry. We looked at the industry in several areas. And then we had our colleagues from circular economy devising solutions that would help manage this. We had a lot of research done in labs, in the field. We had a lot of interviews. And around that, we had a huge stakeholders engagement process, which we'll talk to you about. And so we come up in the end with our set of resolutions. And actually, I'm going to show you here what we have done and where we will be today. This is the plan for the afternoon. Basically, we're going to show you, we're going to tell you what we have on marine litter and how EPS and XPS become marine litter. We're going to also showcase a little bit of what we have done with the stakeholders engagement, which is a process which we respected very much. We listened very carefully to our stakeholders, and they helped us a lot produce our results and conclusions. We're going to go through what we know about the industry, what we know about EPS, the solutions that are up there for recycling, for repurposing, and we're going to go into one or two fields which we covered more extensively, like the fish box market, and then we're going to show you the set of solutions that we have, and they are mainly in two fields. One, we have a lot of recommendations for policy makers for improving European, national, and local legislation, and we have a set of good practices which are aimed at the industry, and that's where we will be going. And because we have started it all up within the whole project is very much embedded in the European context of new legislation covering marine environment, covering how we deal with plastics and everything. I'm going to ask Mikhail Papadoniakis. You are coming from the European Commission at DG Environment, and of course you have been with us since very much the beginning, when we were still shaping the project, and at the same time the plastic strategy was being also shaped. And of course the European context is where the project has been developed. So could I ask you to give us that context?
Thank you very much, Sandra, for the invitation, and also, or mainly, for the good work that you have been doing all these years. We will hear a lot about the content of the project, but I would like, before, let's say, giving what I hope will be a helpful overview of where this project comes in European, let's say, legislation and initiatives against plastic litter. So before talking about that, I would like to highlight a very important characteristic of this project, that it managed, in my view, to link project work with policy development, which is not always the case. I can tell you I've been spending a lot of years in the European Commission, working with projects of various kinds, and also with policy development. And it's a rare, a lot of European taxpayers' money is going to these projects, and we do not always have, let's say, from the policy implementation point of view, the results that we would have liked. But this is if I may put it that way, a counterexample, and I would like to congratulate Sandra and the other project partners for that. And it's a counterexample in both ways, in two ways at least, not in terms only of European policy, but also in terms of regional policy, because we saw, and we will see also during this afternoon, that there's a strong, so to speak, OSPAR content in this project. And this is also very important, because it is not only about, let's say, the EU, it's also about OSPAR, and it is, last but not least, about the coordination of these two when it comes to marine environment policies. Now, can we, okay. This one. Where should I direct it? Okay. But you see, this is the end. Okay, now we start. So I will not go into the details. You know probably that the new Commission, it's no longer so new, in 2019 introduced the European Green Deal, part of which is the Circular Economy Action Plan and the, let's say, the Zero Pollution Action Plan that we will see later on. And the European Strategy for Plastics comes under the under the circular economy, but of course it has pollution reduction aspects. Now, both the circular economy and action plan and the European Strategy for Plastics pre-existed the Green Deal, but they have been updated to take into account the, let's say, the developments of the Green Deal. So we now have a new circular economy action plan and all the follow-up actions for the European Strategy for Plastics. So circular economy is mainly about rational use of resources, let's say saving of resources, energy and water, and also reducing environmental impact from the use. But it's not only about that, it is also about environmental impacts, as I said, and one of the major environmental impacts which have been highlighted recently is the presence and the impacts of microplastics. So there are several actions in this action plan concerning microplastics. Now, another, maybe the most important to date fallout of the European Strategy for Plastics is the Single-Use Plastics Directive. I will not go into details. You know, I believe, this directive, which was a front runner in many respects. So the idea is to, based on the monitoring data that we had from beaches, from OSPAR, and from the Marine Strategy Framework Directive. So on the basis of this data, we identified the most polluting plastic items, so to speak, and decided to tackle the problem at the source, that is to say, to take measures to reduce the presence of these single-use plastic products, either by banning when alternatives were available, or by labeling, or by other measures. I will not go into details. But I would really like to draw your attention to the last paragraph, because this directive has a requirement which is directly relevant for this project. And we could even say it has been influenced by this project to a certain extent, because these two processes went together, in parallel rather. So we have a very important provision for the banning of food and beverage containers made of EPS. Now, you know, and we know, and we will hear much about it later on, to which extent fishing activities are related to the use of EPS. And the Port Reception Facilities Directive, which is about the management of waste in ports, was also revised as part of the European Strategy for Plastics, and it was revised with a main aim to reduce the presence of marine litter. That is to say, to improve the waste delivery at ports, and also thereby to reduce the presence of litter at sea. And one of the ways to do that, to improve waste management at ports and improve and increase the quantities of waste delivered at ports was to include all fishing boats. Now, the scope of the Port Reception Facilities Directive has been modified, so all fishing boats now, and fishing ports, of course, are included, which is relevant for this project. And the other very important novelty is that this directive, in connection with the Single-Use Plastics Directive, creates a coherent whole in the sense that for the products covered by the Single-Use Plastics Directive, which are fishing products, because the Single-Use Plastics covers also fishing gear, so for many of these products, the extended producer responsibility is introduced. That is to say, the producers have to make sure to how shall I say, guarantee the financial viability of schemes to recover and recycle the products when they become end of life. And these funds could, let's say, go to port reception facilities, could go to port authorities, which of course need additional resources in order to organize the collection and recycling of fishing gear containing plastic or other plastic products related to fisheries. Now, as I said, the Zero Pollution Action Plan is part of the Green Deal. It has very concrete targets to be reached by 2030 for plastic litter and for microplastics. I will not go into details. I just want to highlight that, of course, for the achievement of these targets, the Marine Strategy Framework Directive will be instrumental, and they have been based mainly on the possibilities that this directive gives to member states in terms of monitoring, in terms of target setting, in terms of measures, but also, of course, it has been based, these targets have been based to the Single-Use Plastic Directive, and we are doing our best to, let's say, improve the collaboration at regional level. We have, and we see that in OSPA, we have regional targets which are compatible with the Zero Pollution Action targets. And of course, the European Union, which is a contracting party to OSPA and to other regional sea conventions, supports the regional plans. Sandra explained earlier on the origin and the content of the OSPA action plan against marine litter. So the Commission supports in several ways the implementation of these plans, including by projects like this one. And I think it's worth keeping in mind that this project and another European project, Clean Atlantic, let's say, ensured the implementation of an important number of actions of the OSPA Regional Action Plan for Marine Litter. Now, this is not directly related to the project, but it is related in the sense that the framework for marine environment protection in the European Union is the Marine Strategy Framework Directive. And we have decided under this directive to put regulatory thresholds for the presence of litter. And this was, again, the first time that this happened worldwide. So we have, after a long discussion, and Sandra knows this discussion very well because she was directly involved and very helpful. So we have decided there should be no more than 20 items of litter per 100 meters of coastline. Now, this might be or might seem to some very ambitious. In some cases, it has already been achieved in some European marine regions or countries or beaches. But again, we need to work towards that. And of course, we have to see how this will be achieved through intermediate targets and also through taking into account the transboundary pollution, which is a very important aspect. Now, as I said, this is an ambitious but achievable objective. But in order to achieve it, we have decided to set intermediate measurable targets, and we have tried here, I will not go into details, to monitor the trends of marine litter on the basis of the data, of course, that the member states provide. So these data are still being analyzed, and we hope that in the end they will show a negative trend in terms of litter quantities. But as I said, this is still under analysis. Now, if you see the first line of this, because again, under the European legislation for the marine environment, we need to set regulatory thresholds, that is to say limits, which should not be exceeded, for a number of categories of litter, coast, bottom, seabed litter, and so on and so forth. This has been done, as we said, for the beach litter, and it's ongoing work for the rest. For some, let's say, compartments like the sea floor were quite advanced. We hope to have a baselines and threshold next year. It is difficult but necessary work. Now we come to areas which are closer to the project work. The packaging directive, which is under the revision. So I will not, because I'm afraid I have taken already too much time. I think this is going to be published tomorrow, the Commission communication on the biodegradable and bio-based plastics. So I will not say any details. I will save the surprise for tomorrow. This is also part of the, as you can see, the use of, let's say, recycled plastics in new products is being stimulated by a requirement to have a minimum quantity of recycled plastic in new products. Of course, this is not so easy to implement, because you have to, if you look at the top right, you have to agree how to measure, how to monitor this recycled content. But again, it's ongoing. Microplastics, there are two fronts here. Microplastics, which are directly introduced in products like cosmetics, paints, detergents, and so on. And these are going to be restricted. Some of them are going to be banned through the European legislation on chemicals, which is the REACH regulation, and other microplastics which are produced during the life cycle of products, like, for example, the plastic pellets, which is the raw material for all plastic products, textiles, and so on. So the unintentional, so to speak, microplastics, we are working on that as well. I hope that in the beginning of next year we'll have, let's say, Commission proposals. This remains to be seen. Again, this is an overview of what we, of course, the Urban Wastewater Treatment Directive and its revision are very relevant for microplastics, because the idea is to include this emerging pollutant along with other emerging pollutants in the wastewater treatment, but not and now also to include in the wastewater treatment the stormwater management, which is stormwater is a very important carrier and vector of microplastics. Now, we should start with this one, which is it's not exactly a research project, but still I am sure that the scientific community has participated and has contributed and is very interested in this project. So we have now the new research program, Horizon Europe, with several novelties, one of which is the mission lighthouses. The missions to start with, and one of the missions is the protection. Okay. Now this is something that shouldn't happen. Okay. If I want to go up here. So one of the missions is about marine and freshwater ecosystems. Restore our oceans and waters. And you can see here there are three main pillars. I will not go into details, I don't need to read that. The reason why I put this and the next slide, which speaks about the regional hubs, the regional lighthouses, so to speak, of this mission, is to draw your attention to the opportunities that exist, because marine pollution and protection of marine biodiversity is a major theme in this mission. So, the Portuguese host mentioned in his intervention earlier today the groundbreaking UNEA resolution, United Nations Environment Assembly resolution about the plastic agreement. As we speak, the first major meeting takes place, I think, in Uruguay. Yes. So again, this is a very important development, a unique opportunity to reduce plastic pollution, but also let us not forget that this plastic pollution, because this resolution is about reducing all plastic pollution, including upstream production of plastic and so on and so forth, but we should never forget the link of the plastic pollution with the marine environment pollution, because this is how we became aware of that, to put it that way, and this is where everything ends up, unfortunately. All the plastic waste that is not collected on land ends at sea, and this is where we see it, or we don't see it, which is even worse, and this is where it creates most damage. Thank you.
Thank you very much, Mikhail. We will be talking later about the recommendations that we have that fit the bits of legislation that you have mentioned. I would ask, as you mentioned, the Green Deal, the European Green Deal has come up in the middle of the development of the project, and we were anyway taking great care to review all the European legislation which has links to and which is relevant to Oceanwise. And one of the reports that we did was precisely on the linkages between the Oceanwise project and the Green Deal. And I would ask Maeve Thornberry to tell us a little bit of that report. Of course, all the reports of the project, there's almost 20 reports. They are all in the project website. We showed them there a little bit for you just to tease you, but then go back. What we can do today is tell you a little bit of what we've done.
Bom dia. That's it in my Portuguese, I'm afraid. Folks, I started on this project in 2018. I've worked for 2 of the Irish partners, and it's amazing that in the time the project started and where we are now, marine litter has suddenly become a hot topic. So when we started this, it felt a little bit like, why is anybody looking at this? Now this is a great project. And one of the really important things that was said to me at the very start was, this is not a project for project's sake. We are not doing this research because we just want to do research in this area. It goes back to what Mikhail said. This is taxpayers' money. That's our money. We're all EU taxpayers. So it's important that the project has tangible outputs that stakeholders can come away and feel that was a good use of money. So when the Green Deal was announced, it was pretty cool to discover that there were some very strong linkages between what the project was setting out to do and what the Green Deal was saying needs to be done. So very quickly, obviously, there was quite a number of objectives in the Green Deal. So I just picked on about 5 that I thought were particularly relevant for Oceanwise. So one of those is increased use of recycled materials. So one of our outputs is lots of EPS can be recycled, and you can recycle it into really useful stuff. So there's a really strong link. Another one there is increased collaboration. And the research that we've done, the data we have found, the reports we have written have really emphasized the importance of lots of different people, lots of different stakeholders coming together. Because if they come together and collaborate, there are definitely ways to make good progress in terms of recycling, reducing the amount, and ultimately making sure that less of this stuff goes into the environment. Promote job-intensive activity. I know I've been in those yards where they crush the EPS fish boxes and watch it been condensed and watch it go onto a truck. I've been in the centre in the Midlands in Ireland where Waste Matters puts all of these bricks on pallets and it ships them to Europe for conversion into insulation. It is manual intensive work, so that's a really good, this is not something that machines can handle easily. So there's lots of opportunities for job creation. More energy efficiency and renovation initiatives. We all know that retrofitting, making our buildings more energy efficient is a really, really important part of our journey to carbon neutral by 2050. So again, one of the outputs is saying you can take recycled EPS and you can turn it into things like insulation. So there's a demand for retrofitting more insulation. Here is a product that can meet that, and it's recycled, and it is making sure then that the requirement for virgin material is reduced. And finally then, improved policy making and better regulation. And with all due respect to our policymakers, sometimes they're making policies in the absence of a huge amount of data. And ultimately, this is what Oceanwise has produced, an enormous amount of data, research, reports that hopefully you will find both interesting and informative. And that should feed into better regulation, because policymakers, the more data they have, the better informed they are to make better decisions. So the Green Deal is obviously a very important pillar of what the EU is about, and hopefully the Oceanwise project overall fits into that, because ultimately it is all about reducing the amount of EPS and XPS litter that goes into the marine environment. And that's it. Thank you. Obrigado. That's the other word.
Thank you, Maeve. As Maeve mentioned, we took great care in engaging our stakeholders. We did it across the 5 countries of the project. Professor Leah Vasconcelos was coordinating this massive process throughout the whole of the project, and we'd ask you to present how we did it.
Okay. Hello, everybody. Welcome to Portugal, the ones coming from outside, and to the sunny day. I think tomorrow you'll not have so much luck. Sorry. We have been under rain for the last time, so welcome. So I'll be talking about the stakeholder multi-platform approach and collaboration to promote a strategy of convergence. Well, let's see if I can. Okay. This is divided in 5 areas: framework, Oceanwise, stakeholders engagement, stakeholder mapping in Atlantic area, dialogue living labs, and finally reflection on the Oceanwise process. What did we learn? What the stakeholders taught us about the process, and what did we reflect about? So about framework, we are working more and more in context of complex and uncertainty, and we have to evolve from the old ways, the traditional formats, to new ones if we want really to bring stakeholders to the table. And that means that our macro policies that are so great frequently don't reach the local level. And we need to reach the local level. We need to transform this abstraction of policy to something that the local level understands, gets involved, and contributes. And that's what we try to do in this project. So we wanted to mobilize an engaging goal in terms of collective intelligence building, social labs, deliberative democracy, open forums, and living labs. The idea is to put everybody together discussing an issue that they have a stake at. And if we really succeed, it leads to innovation, because we are doing something like providing spaces where different knowledge cross, merge, and produce new knowledge and innovation. So it's a value added if we can make the most of our society. People are key elements for social transformation, and knowledge, not only the technical scientific knowledge, but all the knowledge, are very important to unleash and to lead to the growing of collective knowledge, building new one. Knowledge is not accumulation of information. It's much more than that. It is competence to act. And that was what was behind when we started this project. So Oceanwise stakeholders engagement. We did an approach, a wide view angle, putting together multi-sectorial platform involving governmental bodies responsible for marine environment management, industry, other stakeholders as waste management authorities, designers, circular economy experts, research, ID specialists, and end users. And the idea was to develop specific actions to promote and ensure active involvement of the different key stakeholders. So it moved through different phases. A first phase that was stakeholder mapping in the Atlantic area, dialogue in living labs, stakeholder engagement tools, and building together eco-innovation that we'll be talking another intervention today. The stakeholders mapping in the Atlantic area were concerned in identifying stakeholders related to EPS in the Atlantic area based on a checklist of all likely stakeholders conducted by each project partner. The stakeholders were characterized by relevant macro groups, taking into account the entire life cycle of the EPS products, so it involved researchers, manufacturers, users, and recyclers, and by the sector of activity. We came out with 994 stakeholders coming from raw material supplier, EPS products packaging industry, retail supplier industry, final consumers, end of life, policymakers, and alternative EPS products. So you can see how diversified it were the stakeholders that got involved in this whole process. In the dialogue living labs, and you can see some pictures of what went on in these living labs, we approached the involvement of stakeholders and experts in dialogue, trying them to collectively first build an agenda, because the agenda in this complex context cannot be just the agenda of the technical, scientific, and political arenas, but they have to be an agenda of everybody that has a stake on that issue. And that's what we did, and that helped us to phase and structure the whole participatory process. The collective knowledge emerged from these collaborative forums, and it showed how valuable the contributions were, and you can see by the results of the project. The living labs were organized in two big phases, a diagnosis phase and a co-construction phase. The first one was to set the agenda and to develop proposals, and the second one was to share results, not only nationally, but also internationally with all the partners, and finally to wrap up the project. We involved 338 stakeholders from various sectors of activity, directly or indirectly related to the EPS, HPS life cycle. And in the diagnostic phase, we explored the relation between EPS, HPS, and the circular economy. List of benefits and opportunities and constraints and concerns relate to EPS and HPS of all the stakeholders involved, identification of priorities to be addressed, and we elaborate a roadmap for EPS and HPS, the items in order to target 100% circular economy. In the co-construction phase, we developed 47 short-term actions and strategies, and we came out with a list of 15 recommendations on EPS, HPS uses, and our alternatives for each priority. Reflecting on the Oceanwise stakeholder multi-platform, we can show you what the participants said about this whole process. They learn about EPS and HPS and materials made from them, the importance that showed them of communication and collaboration platforms. They highlight also the importance of using the media to reinforce the dissemination of the EPS, HPS topic and its impacts, and also they mentioned the knowledge transfer promoted by the project. So, in terms of findings and conclusions, stakeholders' engagement is essential for improving the end-of-life management of EPS and HPS. Many industry sectors are or should be involved in the recycling or safe disposal of end-of-life EPS and HPS products, and outputs from the workshops pointed to certain strategies and actions that the stakeholders agree were required to address the primary aim of the Oceanwise project. Thank you very much.
Thank you, Leo. We can only begin to highlight how much this process is important. It basically showed us how many times the devil is in the details, but it also showed us so many times how heaven is in the details. We learned from the stakeholders every day, and they helped us shape the conclusions. So the project basically was made by 13 partners and 38 stakeholders that helped us all along. And so of course, from the beginning, we were challenged, and then it was our aim anyway to find out exactly what was the problem of EPS and XPS in the marine environment. We knew a lot from the work that we do collectively at European level on the monitorings, and we asked our partner CEDRE, and Sylvain André will start, and then Camille Lacroix will continue to tell us about the presence of EPS and XPS in the marine environment, and then about its impacts in the environment.
Thank you, Sandra. So I will present you the work we have done about the assessment of the presence of polystyrens in the marine environment of the Northeast Atlantic. This work has been made in 3 parts. The first part is about a quantitative analysis of EPS and XPS based on data we have gathered from databases of the Northeast Atlantic. And then we have made a qualitative analysis of the pollution in the marine environment, going on site. And finally, we have gathered qualitative information on identified pathways and sources. First of all, about the abundance and distribution on the coastline. EPS and XPS are common and abundant litter types in the marine environment. Based on OSPAR beach litter monitoring data from 2018 to 2020, because before existing data, polystyrens were not separated from other plastics. We have observed with this database that 13% of the litter collected were polystyrens, and the distribution in the Northeast Atlantic were heterogeneous, as you can see on the map here with the different sizes of the circles. And a big problem is that the pieces under 2.5 centimeters were too numerous to be counted in some cases. So it is to the next thing we have observed that the polystyrene's pollution is a multi-size pollution, and it is mostly fragmented. Fragments represent 97% of EPS and XPS pollution we have observed. Because this material is fragile and easily breakable, and it has a high dissemination potential because it's light and it can be transported by wind and currents, and it can be found everywhere, so it is a pollution very difficult to tackle. And we also observe multiple sizes in the environment, from very large, as you can see with a big block on the coastline, to very small sizes like powders and very small particles of certain millimeters. The EPS and XPS pollution can also undertake aging. In the marine environment, we can see a photooxidation, a kind of yellowing phenomena with a powder on the surface of the materials, and erosion due to photooxidation and or mechanical erosion. You can see the tiny balls are curved by erosion on the surface of the fragments. It also interacts with biota in different ways. It can be ingested by wildlife by being confused with kettle bones or other food. It can be colonized and transport of species, and sometimes over long distances. It can be an habitat for border organism being excavated and leading to production of microparticles. And it can also interact with dunnal plants because with it may be potential properties that facilitate plant growth, like keeping humidity. It can be colonized by plants. About the pathways, there is different pathways that are known to discharge EPS and XPS in the environment. Like the rivers, you can observe here a piece of polystyrene on the river side. urban water systems. On the photo here, it is a sample of pollution collected on urban water systems. And you can see on the bottom of the photo a lot of polystyrene pieces from large to very tiny. And in the bag of the photo, you can see it is also polystyrene particles. And we also observe polystyrene during extreme events. About the sources, they are multiple and it is very difficult to assess their contribution. We can cite fishing, aquaculture, food packaging, construction, fishing transport, and others you can have in mind, maybe. And it is really difficult to determine the contribution of these sources because most of the time, as we have seen, the polystyrenes are fragmented and it is not possible to determine the source. So to wrap up, EPS and XPS are frequent and widespread in the Northeast Atlantic area, and it is a multi-size and mainly made of fragment pollution. It can also interact with biota in several ways we have seen, like ingestion, colonization, transportation, habitat. And rivers, urban water systems, and extreme events are pathways of discharge of EPS and XPS in the marine environment. And finally, about the sources, they are multiple, and their contribution are difficult to assess. That's it. Thank you for attention. Thank you.
Thank you, Sylvain. Thank you. So we know about the presence of EPS and XPS in marine environment, but then of course what we need to know is about its impact in the environment. That's what we're worried about. Why is it a problem? So Camille Lacroix, also from CEDRE, we'll ask you to tell you this part of the story.
Bon dia. So I will now complete Sylvain's presentation by another part of the work we conducted during the Oceanwise project in collaboration with our colleagues from CFAS in the UK. So Sylvain presented some data and observation made in the field, and I will now present some experimental work we conducted during the project in order to collect and get more information about potential impact of EPS and XPS in the marine environment. So with our colleagues from CFAS and with the CEDRE team, we work on 3 EPS and XPS products that were selected with all the Oceanwise team. We decided to work first on an EPS fish box, also an XPS food box, and an EPS insulation board. On these 3 products, we conducted several experimental work in order to assess macrofauna colonization, material weathering in the marine environment, transport of contaminants, and also toxicity on marine organisms. We conducted either work in the laboratory, but also at pilot scale and in the field. You have here some picture of the different experimental assays and work we conducted at both CEDRE and CFAS. So what did we learn with all this experimental work? The first result, main result, is that EPS and XPS can transport species. Indeed, we put some of the 3 materials in Brest Marina for several weeks, and after some time in the seawater, we were able to observe colonization, indicating that EPS and XPS can be colonized by macrofauna, and in this context are able to transport species over a long distance. And these species can be non-indigenous and invasive, so they represent a risk for the marine environment. The second finding were about the aging. Sylvain already talked about the aging and the observation of EPS age when collected on the coastline. And we confirmed this when doing artificial weathering artificial photo-oxidation in the lab. You have here the 3 products we worked on during the project. First, at the top, before aging, and after 3 months in an aging chamber. And you can see very easily the evolution of the surface, the yellowing, and the release of powder after the photo-oxidation. We also showed that EPS and XPS can contain potential contaminants. Indeed, we performed several chemical analyses on the 3 materials, the 3 products, and we were able to detect and quantify either PAH, polycyclic aromatic hydrocarbons, which are toxic contaminants, and plastic additives in the 3 materials. You have here some results obtained during the project. However, we were not able to observe an important transfer of this contaminant in the seawater. They appear to be released not quickly. They are slowly released in the marine environment, in the seawater. However, they are present in the material, so they represent a risk. We also observed that EPS and XPS can absorb toxic contaminants when they are when they are placed in contaminated areas. Indeed, after putting our 3 materials in a contaminated harbor in Brest Marina, we observed an increase of the contaminant concentration at the surface of the 3 materials, indicating that the 3 materials are able to transport contaminants. We also showed that EPS and XPS contain compounds which are able to generate toxicity. You have here some results we obtained when we tested the toxicity of solvent extracts of the 3 materials. On these solvent extracts, we observed some developmental effect on a fish, Danario. It was rather low, but still significant. We also observed some DNA damage on cell culture, not on all materials, but on certain materials we were able to detect significant effects. And last but not least, for the 3 materials, we also were able to detect and quantify some endocrine disruption on cell culture, which can be related to the presence and endocrine disruptors in the 3 materials. However, despite this presence of toxic compounds, we showed that at environmental concentration, there were no significant toxicity of the different products tested on marine organisms when we tested the toxicity of seawater leachates. And you have here some example of result obtained on the survival of a copepod, which is a small crustacean, and also on marine bacteria. So we were not able to see a very significant effect, except in some rare cases. So what are the key messages of this work? First, we showed that, like other plastic materials, EPS and XPS can induce several types of impacts. It's not only toxicity, it's not only macrocolonization and transport of species. No, it's a combination of several impacts on the marine environments. And we also showed that the 3 tested products can be colonized by macrofauna and transport species. We showed that they contain PAH and additives, though there were low capacity of transfer in seawater on the short term. We also showed that these materials can absorb contaminants when immersed in contaminated seawater and contain toxic compounds that can generate toxic effect. However, at environmental concentration, we were not able to detect overall a significant toxicity. overall, we confirm that these products can raise concerns. The impacts can be complex, and they have to be considered on their together. Sorry, to have a complete view of the risk associated with these materials. Thank you very much.
Thank you, Camille. There's a lot of data in the research reports, and a lot of more investigation done. So we knew, of course, at this point, and it was obvious from the beginning, we had to then look into how EPS and XPS are used, produced, how discarded, how the end of life happens, and we had to look for solutions within that. But we started. One important thing is our starting point. We knew that not all EPS and XPS products end in the marine environment. We don't expect to need to take care of EPS that is inside a fridge door, isolating it to be a problem. The whole fridge will be a problem. So we were looking into what are the priority materials, products that can end in the sea, and that will be that was the focus of our project. So we looked a lot into the fishing industry because it happens not so far from the sea, and we had fish boxes, fragments of fish boxes detected in our monitorings. We looked at also all the small pieces of products that are made in single-use products, like the one that is used in supermarket chains and also in takeaway foods. We looked also at the EPS that is used for protecting, for example, electronics goods that you take home and then you have to discard as an end consumer. And we looked at everything that products that might be used near the coast. Brian, I'll let you from that, because then from that point, of course, we will dealing with building a knowledge hub around the industry and the uses of EPS and XPS.
Thanks very much, Sandra, and good afternoon, everybody. My name is Brian Walsh, and I'm from Repack. So we covered two work packages within the project. One which was looking at the whole area of the industry itself, the EPS industry and the XPS industry. Who were the main manufacturers? How many of them were there? What the applications and uses of EPS and XPS were, and also looking at the end of life and the opportunities for better waste management and recycling of the material. So I suppose one of the key aspects of this in terms of looking at this whole area is the marine litter risk, and obviously what Camille has just covered just mentions what that risk is. But I suppose what we were trying to establish with this is what are the points at which EPS and XPS present the greatest risk of becoming marine litter in the first place. So I suppose the first part of it, and the obvious part of it, is during production and transport of it itself. So the industry itself has taken upon itself, I suppose, to do some work around this, and there is a set of guidelines which have been adopted through Operation Clean Sweep, which is an industry initiative basically designed to try and stop plastic, resin, flake, and pellet materials ending up in the marine environment. So again, taking those guidelines and making them standard practice or a regulation that the industry should actually follow is something that we believe is something that could be considered. During the use phase, I suppose to mention that the SUP directive has obviously helped to eliminate EPS from higher risk on-the-go packaging, so packaging that's used when people are out and about, and it's more likely to become litter. I suppose it's important that where possible, get out of jails exist. They could do with being closed off where possible, and it's important that we cover extruded polystyrene in the terminology there as well, so that the industry can't necessarily argue that, well, you guys said expanded, this is expanded, this stuff over here is extruded. So it's again another recommendation, I suppose, from that particular review. Construction applications, I suppose, we looked at in detail because obviously extruded polystyrene and expanded polystyrene are both used for a similar purpose within construction. So, for example, they're both used in insulation. They can also be used in building facades and other applications, such as your external insulation and internal insulation blocks. So EPS releases small beads during cutting, for example, that can blow away during construction activities. It's also possible, that during disposal, if it's put into, a skip or a bin with an open top, on a windy day, again, it can blow and create litter. So again, prevention measures and guidelines for the construction industry would be extremely useful within those particular areas. Fish boxes, we actually found, it should be relatively low risk across the countries that were looked at. What we tended to find was actually not a lot of it ended up offshore, and the majority of it ended up onshore. So there's a real opportunity there to be able to deal with that and make sure that that's prevented from becoming marine litter. Other offshore uses, such as in pontoons, present a certain risk, although it tends to be medium, but can become high risk during, for example, during adverse weather conditions such as storms or something like that, where they could potentially break apart and end up close to the coastline. In terms of the end of life, so again, we will deal with this in a little bit more detail in a moment, but the highest risk is certainly presented by post-consumer waste. And what we found was, we will deal with this in the other work package, but the condensing option, for example, that Maeve mentioned earlier, it lends itself a lot more to business and can be set up at a fish processor, for example, or a number of fish processors if they're in the same area to deal with fish boxes, for example. So just going to go into a little bit more detail on a couple of things here. Spent quite a while on that first slide, sorry. But in terms of our first work package, the deliverables really were to construct a database on EPS products and applications. So we looked at how much EPS and XPS is actually on the market, where it is, and what are the key sectors using it, what is it used for, and who are the key manufacturers and stakeholders involved in it. I suppose, first of all, to just give a little bit of background, I suppose, to plastics in Europe in terms of both its production and demand. Global production was 367 million tonnes in 2020. And Europe made up about 16% of that total, or 57.9 million tonnes that should be 2020, apologies. So European demand from actual plastic converters and manufacturers was 49.1 million tonnes in 2020. So So obviously the remaining tons were exported to other markets outside of Europe. Packaging makes up the largest share of the market at around 40%, and about half of that is building and construction, so it's next largest at just over 20%. And the balance then goes into agriculture, automotive, and others. So the focus then in terms of the actual EPS and XPS figures. So EPS production was at about 1.5 million tons in 2020. The XPS figure is included within actual polystyrene production figures, so it made that a little bit tricky to actually identify. The report found that there was around 396 EPS manufacturers and 42 XPS manufacturers in Europe, and the largest concentration of production facilities was actually found to be in Italy. So the two materials are kind of separately represented. So UMEPS covers EPS and XEBA covers XPS, and they're both trade associations associated with those material manufacturers. In terms of the applications and uses, so I already mentioned in terms of building and construction, so it's insulation panels, facades, and it also goes into things like building foundations as well. In terms of packaging, there's a range of different things, but one of the biggest applications is in cushioning materials, for example, for electrical appliances, protecting them during transport. Fish boxes. It's also commonly used within the cold chain for pharmaceutical packaging, as well as horticulture and kind of fresh produce, fresh foods. In terms of components, it goes into all sorts of things, such as everything from cycling helmets to headrests in cars and other seating, as well as other items such as surfboards. XPS, on the other hand, I suppose the applications are a little bit more limited. It's mostly used in construction, but again, there are some packaging applications there, such as XPS meat trays and clamshells, or similar to what you see on screen there, but with a lid basically covering it. So, again, mentioning the SUP directive, strictly speaking, those clamshells and meat trays, if they were used for products that someone takes away without any further preparation, wouldn't necessarily be covered in that directive at the moment. Sorry, that slide is up there again. Okay, so do you want me to cover this now, Sandra? Yeah. Okay. Yeah. So just moving on then in terms of the end-of-life opportunities, and this again covers the whole area of waste management and recycling of those materials and kind of the current status of that. In terms of the deliverables here, so again we had to do some fact sheets on the current solutions to recycle, reuse and repurpose EPS across the focus countries in Europe, and provide recommendations in relation to possible end-of-life options for the treatment of the materials. So what are the challenges? I mean, why is this material not considered readily recyclable at the moment? There's a number of reasons for it, which I suppose makes it different from other rigid or solid plastics, if you like, or flexibles. It's effectively made using 98% air, and that in itself is a challenge, because what it means is you have quite a high volume to weight ratio, which makes it very light, but it takes up a lot of space, and that makes it extremely expensive to actually transport and deal with from a recycling point of view. Its brittle nature also means that it is generally not accepted for collection and sorting at the household level. If it goes into material recovery facilities across Europe, it gets onto conveyor belts, it breaks up, and it contaminates other materials, particularly where there's a situation where the materials are kind of mixed together and sorted through that process. There's also, quite a limited and inconsistent recycling collection across Europe. Mainly probably because of that latter point. In terms of recycling facilities, what we found through the research was that there was 154 EPS recycling operations within the focus countries. There were significant variations found in EPS recycling rates from country to country. So, this ranged from 0% right up to around 60%. There was no separate data available again in terms of extruded polystyrene, because generally that data was lumped in again with polystyrene, so would have included non-foamed rigid versions of extruded polystyrene. Some take-back schemes exist where businesses basically will accept back consumer waste or customer waste, but again, there's nothing necessarily obliging them to do that. UMEPS, the EPS Trade Association, have set their own recycling goal of 46% by 2025. And at the time of the research, there was no such goal from Exiba to do something similar. In terms of solutions then, so again, compacting this material is really key. It eliminates the air, it reduces the volume, and that makes transporting the material feasible to enable recycling. So the solution is feasible for B2B and is already in use in a number of countries. So for example, Maeve mentioned Waste Matters in Ireland earlier. They do this where they collect from a number of fish processors in one of the main fishing ports, and they have a mobile unit that basically comes around and covers that entire area and compacts the material and then sends it away for recycling. The pictures you're looking at there are Billingsgate Market in the UK, where again they're doing something quite similar to that. B2C, or at the consumer level, is a lot more challenging with limited acceptance of the material for recycling. In fact, there are some recycling centres that won't even accept the material for recycling. So again, adopting something similar to this, where municipalities or councils or local authorities set one of these machines up in a recycling centre to enable this would certainly help to increase the recycling rate. And that's me. Sorry, I probably took way longer than I was supposed to there, but
I guess you could go on.
Sorry,
you could go on for forever, because this work is so extensive. It informed.
Absolutely. Sorry, I just wanted to say a thank you to our partner in research on this as well, Maeve Thornbury, who helped support the project on behalf of REPAC. So thank you very much.
Thank you, Brian. Yes, as Brian said, of course, one of the EPS products that can be contained if it's managed properly is the fish boxes, the EPS fish boxes, and so we did a lot of specific work on that, and Julio Maroto from Fundación Setmar is going to tell us about that. We were looking into the specifics of this market to find solutions.
Okay, good afternoon to everybody. Sorry. Okay. I would like to give you some details about the study we made about the topic that appears in this first slide. Okay. And there are several reasons that justify this study, but I think that the most important is the first one. This fresh fish sector uses large quantities of EPS boxes and in consequence generates high tons of EPS waste. There are another reason, but undoubtedly this is the most important. About the auditing, it was knowing in detail the commercial flows on the value chain of this fresh fish sector, the points where DPs, EPS boxes begin to be used and where the waste is generated. Identifying gaps or management practice where improvements could be introduced, and finally increasing the amounts of waste that can get recycled. In this slide, we can see the methodology. Well, we had a good previous knowledge of the sector and the study. We identify all the stakeholders implied in the trading fresh fish sector and in the waste management cycle. Additionally, we had meetings and discussion with the stakeholders, with the different stakeholders, and with this all information, we made diagrams that include all the stakeholders and the flows of goods and waste. In this first, this flow chart represents the value chain of this fresh fish activity, okay? Include all the types of companies involved in the value chain and additionally including aquaculture. It's a diagram valid for any country in the Atlantic area, even to any country, European country. Although the different companies have a different level of importance in each country. We can appreciate the path and the possible changes among the stakeholders in the chain. We can see in different colors the goods sold in EPS, in EPS, or other packaging, and the final product reaching the final consumers is never packaged in EPS, but sometimes is packaged in EPS. Okay. In this second diagram is a flow chart about EPS fish boxes and their waste. So besides the stakeholders that we just have saw in the previous slide, in this diagram include these other stakeholders involved in the management and recycling cycle. We can see what the EPS waste are generated and which path they follow in the management and recycling chain. Industrial and commercial EPS waste should follow the path of authorized waste manager to reach a correct recycling in recycling polymers production companies. I mean, specifically this row in red color. Okay. And nevertheless, an important part of commercial EPS waste wrongly follow the path of the municipal waste management system and how domestic scraps, so they cannot be recycled properly. This other part. Okay? Well, some consideration and possible improvements. Well, promoting reverse logistics systems, especially in these two kind of stakeholders. To create a multi-material extended producers responsibility scheme to include EPS waste, create a new fraction of EPS, XPS in the material recovery facilities companies, increasing undoubtedly the rates in municipal landfill, and creating recycling spot in big central market and local market. Now, in this slide, it's a slide focused to the material alternative to EPs, okay? This diagram is very similar to the previous diagram, but includes the use of alternative materials. Both type of boxes could be used at the same time by trading companies, and this would generate mixes waste of both types. So EPs, traditional EPs, and bio-EPs, okay? Important remark, mixes waste of EPs and bio-EPs cannot be recycled together. It's absolutely necessary a good separation. To know the matter is just theory because the presence of bio-EPs boxes in the market is very limited. Some consideration that came from this diagram. Well, compostable bioplastic cannot degrade in the marine environment. Composting is the only end of life for these materials. Additional problems is necessary a separation between EPS waste and bio-EPS waste. They don't represent a raw material for the composting private companies. The degradation time during the composting processes is very high. It's higher than the normal, habitual ingredients in the composting process. And finally, there is not an agronomic demand of this type of compost. And that's all. Thank you for your attention. Muito obrigado. And if you can find more details about this study, you can find this detail in these links, okay, on the website of the project. Thank you very much.
Thank you, Julio. So before we jump into more of the recommendations, specific recommendations, we need to tell you that, of course, we also looked very much into the alternative materials. Should we suggest change in some areas, in some usages for alternative materials? Do they behave well in the environment? Are they safer? And so we did a lot of work on that field. We can only begin to tell you today a little bit of it because, of course, we don't have the time to be here for 3 days, which we could on that field. But we want to tell you how careful we were and what kind of work. So we have a small video to start to frame this subject sent by our colleague Josie Russell from CIFAS from the UK. Last minute she could not make it here, but we want to. She sent her presentation on a video, which we'll show now.
Good afternoon, my name is Josie Russell. I work at CIFAS, the Centre of Environment for Fisheries and Aquaculture Science in the UK, and I'm going to present some of the work we did with Seabird as part of the Oceanwise project, looking at alternative materials to EPS and XPS. The full report and list of current alternatives available can be found on the Oceanwise website. Many alternatives already exist and new ones are being tested. There are an array of different materials that can cover an entire range of applications. The decision to adopt to an alternative to EPS and XPS depends on many factors, and I want to start by focusing on what really is at stake when considering alternatives. It's really important to understand that all materials have an impact. The issue isn't just EPS or XPS, but also how we use it. Reducing or reusing items should always be a priority. There's wide recognition that single-use items are problematic, regardless of their material, and it's important to consider the whole life cycle of the item, including the fate of end of life for products. We don't want to replace one problem with another, and more research on the life cycle and the impacts of all materials, including plastics, is still needed. Thanks to their durability, low weight and insulation properties, EPS and XPS are nowadays used for several applications, such as the transportation of fragile or thermally sensitive goods, the production of buoyant devices, or the thermal and sound insulation of buildings. Both foams are waterproof, strong, durable, with high compressive strength and block rigidity. They can also be easily moulded into different shapes, and they have high design versatility. When considering alternatives, it's important to understand the properties needed and to consider specific applications, rather than just finding a material to replace all EPS or XPS. There is some confusion about the use of terminology like bio or compostable. The bio denomination has been linked to the wrong perception amongst the general public that all these polymers, once abandoned in the environment, will automatically biodegrade because of their origin. The term compostability of these polymers must also be specified, since the use of the term compostable can sometimes hide the need for industrial composting facilities, which have different conditions compared to home composting. Industrial composting is not always available, and items can end up at landfill or being incinerated. The use of home composters to get rid of industrial compostable polymers is linked to partial degradation and fragmentation, with the possible production of microplastics instead of mineralization. More stringent standards should be implemented to ensure that only certified claims can be used for marketing. Biodegradability and compostability, either at home or through industrial composting, are desirable characteristics, but their certification is necessary to ensure the impact on the environment is reduced. Sometimes the compostability, biodegradability, or recyclability claims refer to the materials and not the final products, which might include glues, additives, coatings, or might have undergone other manipulations that could affect the way in which they should be properly disposed of. There should therefore be more clarity in labelling and more stringent standards on the use terms like compostable or bio in order to not confuse users and to reduce involuntary mismanagement. So what are the current alternative options available? There isn't one material which could or should replace EPS and XPS, but there are an array of different materials that can be used to cover the entire range of applications. These alternative materials vary according to the type of application and include other thermoplastic or natural or synthetic biopolymers. When, at the beginning of the 20th century, synthetic oil-based polymers were developed, the use of natural polymers slowed down. But in the last 20 years, biopolymers have again become of interest because of the desire to reduce the use of fossil fuels and also to reduce plastic pollution. The industry has also developed new polymers using precursors derived from biomass. Recent technological innovations have resulted in a substantial improvement in properties, such as heat resistance of these biopolymers, which are now eligible for wider range of applications. Many of the alternatives have a lower carbon footprint than EPS or XPS, although it's not always the case, and sometimes it's higher. The production of thermoplastics like polyethylene and polypropylene, which are oil-based like EPS and XPS, is also not more environmentally friendly than polystyrene foams, unless recycled material is used. Plastics can be a very useful material if they're used in the right way. Some materials are considered more sustainable because they're easier to sort, collect and recycle and feed into a circular economy. Polyethylene and polypropylene are two of the most produced plastic polymers in the world. Their foams are already displacing the use of EPS and XPS in products such as fish boxes, vegetable boxes, bodyboards and floating pontoons. They are, however, foamed plastics, so many of the similar issues such as transporting or escaping to the environment are the same. These types might break up less than EPS or XPS, so there might be a potential reduction of fragments to the environment. Several naturally occurring biopolymers are created by animals, plants, fungi, bacteria, can be extracted directly from living biomass. These natural biopolymers have been used by humans since millennia, both in their natural form and after physical treatments. Some examples are shown on this slide. Things like palm leaves are used extensively in parts of China, South Asia, and West Indies. The leaves are gathered, washed, dried, and shaped into containers using molds. They're biodegradable and compostable. And palm leaf containers can be used instead of EPS or XPS for both hot and cold food. Wool is another example. It's fully renewable and plentiful resource, which is both biodegradable and compostable. It has excellent thermal abilities. It's used in conjunction with other materials, such as cardboard or wood, to line products, which are used to transport deliveries of chilled foods instead of EPS boxes. Some packaging, like these peanuts, are made from starch. They can be composted in household or industrial composters. Some are said to disappear in water. They're suitable replacements for XPS packaging peanuts that are used, particularly already used in the US. And there are things like these mushroom-based biomass, which have been developed as a foam and can be molded into various packaging products and insulation composites, and are 100% home compostable. Mainly made from wood sources, paper and cardboard are used for many different types of packaging. Depending on the moisture and contaminations level, most wood and cardboard is completely recyclable. Paper and cardboard can be used to replace EPS and XPS for certain packaging purposes. Corrugated cardboard in particular provides protective cushioning to products in transit. The addition of a layer of plastic or coating sometimes makes the paper and cardboard suitable to replace EPS and XPS products such as fish boxes. Polylactic acid, or PLA, is a polymer composed of lactic acid molecules chained together. Foamed PLA is durable, resistant, and lightweight. Foamed PLA has been approved for food contact. It's got good thermal insulation properties and multi-shock resistance. It's lightweight and moisture resistance. All of these characteristics making it a valid alternative for EPS and XPS for several applications, which include fish boxes, bean bags, and insulation products. At end of life, PLA can be composted under industrial composting conditions. However, it's not suitable for home composting. It's one of the most produced bioplastics globally, and it can be manufactured from renewable sources such as sugarcane and cornstarch. If it's mismanaged, waste is still dangerous because without the correct conditions, PLA decomposes very slowly, similar to oil-based polymers. So this has been a summary of those current alternatives that are available. Overall, a lot of these materials are more expensive and less available than EPS or XPS. If adopting new materials, we must ensure that they are more sustainable than other alternatives. So we need to support the development of consistent testing and certification standards for biodegradation in the environment and ensure clear labelling. There should be more research into the behaviour, fate and effects of alternative materials and continued innovation and development. It's important to understand that there may be certain niches which are useful to have alternative materials, but ensure the focus is always on that reduction and reuse, moving towards a more circular economy. Thank you for listening.
Okay, and also, can I ask you, Camille, if you tell us then a little bit more also about how these materials behave in the environment? By the way, this special effect that we have here with the sunset hitting the beer ball, of course, we took great care in the production. It's about making you imagine the EPS as it flies in the air when it flakes because it's very light. Now you just have to imagine that the sea is there and not there, and that's how it reaches the marine environment.
Hi again. So I will now talk about the potential impacts of plastics alternative, EPS alternatives in the marine environment. Indeed, Josie, well introduced the fact that it's important to not replace a problem by another problem. And Julio has shown that we can already observe technical problems, especially in waste treatment, associated with alternatives. In our work at CEDRE and in collaboration with CIFA's team, we looked at the potential environmental impacts of these alternatives in the marine environment. And I will show you some results. And actually, we were working on this at CEDRE with CIFAS, but also UBS colleagues address this issue and work on two types of alternatives, PLA and PHA. In form for both. And at CEDRE, we work on three different types of alternatives: PLA fish boxes, PLA plus PBAT fish boxes, and PHA fish boxes, which were selected among the consortium, the Oceanwise consortium, based on the work done by partners. Here are some illustrations of the product we tested. We used a similar approach to the one we applied for the impact assessment of EPS and XPS. So for all three fish boxes, materials which are either bio-based and or biodegradable in the marine environments. Actually, some of them are only compostable. In details, if I can give you some details, PHBH is bio-based and biodegradable in the marine environment, according to the manufacturer. PLA, which was introduced by Josie, is bio-based, but not biodegradable in the marine environment. However, it's compostable in industrial composting. And PLA plus PBAT is also bio-based and compostable in compost facilities, but not biodegradable in the marine environment. On these three materials, we conducted experimental work in order to assess macrofauna colonization, transport of contaminants, and toxicity on marine organisms. I have already gone into details for the EPS and XPS impact assessment, so for the alternatives, I will only focus on the key messages and the main findings we obtained. And it must be noted that the results presented are only obtained, are only available for the tested material. It can be generalized to all alternatives. Our first result was that alternatives can, as EPS and XPS, be colonized by macrofauna, and as such, they can transport species also. Alternatives appears to have a different chemical composition. When we looked at the pH content and also the additive content, we saw less concentration compared to EPS and XPS. However, we can't exclude that different alternatives are used in these materials. This means that as environmental chemists, we need to expand the list of contaminants targeted to also include potential additives used in alternatives. We observed that alternatives absorb less contaminant when immersed in contaminated seawater compared to EPS and XPS. So it appeared to be better on this type on impact compared to EPS and XPS. For two of the tested material, PHBH and PLA plus PBAT, we were not able to detect significant toxicity at relevant concentration. However, we detect some significant effects on one tested material, which was the PLA. And these significant toxicity effects were detected on several biological models. Overall, so as I said, these results are only for the tested materials. However, it confirms that these alternative materials have to be considered with care before being selected as a solution to replace EPS and XPS, as we can't exclude some impacts on the marine environment. Thank you very much.
Thank you, Camille. And then, of course, also we looked into how these alternative materials could be, how useful they could be in the hands of the users before we even start dreaming of suggesting that they'd be used as alternatives. We need to know if they actually can be replaced, can be a solution. And so, Gloria Devine from BIM, can you tell us what we did?
Okay, so thanks for the introduction, Sandra. Bon dia. My name's Gloria Devine, and I work with BIM, the Irish Seafood Development Agency. And for this work package, we worked closely with Setmar in Spain, who also work with the seafood industry. And we were about living labs, testing alternatives in real life scenarios. So working with the seafood sector, it was obvious that we were going to test fish boxes in a real life scenario. So the alternatives that have been looked at in the project so far, and which Camille and Josie talked about, a number of the more promising alternatives then were selected for real life testing. And the number one priority for a seafood processor is ensuring seafood safety, that the fish is safe to eat, and ensuring the quality of that. So we decided to focus on those factors and see if these alternatives maintain that quality and food safety. Initially, at the beginning of the project, the idea was to actually transport fish in these boxes, but because of COVID limitations, we had to redesign our real life trials, and what we did instead was carried out in situ trials for the duration of real life logistics and transportation times. We then incorporated an additional test to look at the strength and durability of the alternative boxes. So these are the alternatives chosen, and all of these alternatives are either getting ready for commercial production or in commercial production. So 3 of them are foamed alternatives, bioplastics, and the 4th one is a cardboard coated box. And as I said, our approach was focusing on food safety and seafood quality. Again, our processes diverged slightly because in Spain, the market for fresh seafood is quite different to what it is in Ireland. In Ireland, we tend to eat portioned, filleted whitefish and salmon and not a whole lot else, whereas in Spain, there's lots of whole fish that goes straight fresh to market and people take it home and do the processing at home, so to speak. So Setmar tested 4 common species, the sardines, pouting, megrim, and horse mackerel. And these were all tested as whole fish. So the fish were packed with ice into the alternative boxes. Small holes were drilled in the boxes to allow the meltwater to escape. And the time to market in Spain is very quick. So typically the fish are placed in the box and, are only there for 3 days. By contrast, in Ireland, we tested Irish farmed salmon, and it was a summer shelf life trial, so it was up to 16 days for 100-gram salmon fillets. So again, our trials lasted a lot longer. All of the tests were conducted in accredited labs, and we tested a number of different parameters. So it was time and temperature, organoleptic factors such as, the actual quality of the fish, the brightness of its eye, the condition of its skin and stuff like that. A number of chemical factors and microbiological factors. And we also then went on to look at the strength and durability of the tests of the boxes. As we said, we couldn't transport the boxes between Spain and Ireland as we initially proposed to do. So instead, a number of tests were carried out at an accredited lab in Ireland at the Technical University of the Shannon. There was drop testing, impact strength testing, and artificial weathering, just to see how the boxes performed. And overall, they performed comparatively well with the EPS when it came to the expanded foam. The test wasn't really fair for the cardboard box because it's a completely different material. So overall, our joint results were, in terms of food safety and food quality and general handling, the alternatives performed as well as the EPS, really. Everything passed the tests. And you know, in the Spanish example, for getting the whole fish to market within 3-4 days, no problem. Sometimes the alternatives perform better. It was all pretty good. Same with the Irish example. There were no limits exceeded in terms of E. coli or anything like that, up to 14 days. So yeah, they're all good. However, Josie and Camille and Brian did raise a range of other factors which also have to be considered, and these are things like cost, availability of the bioplastics or the cardboard alternatives, the overall life cycle. It's all very well if in Ireland we start to use bioplastics expanded foam, but we don't have the industrial composting infrastructure in Ireland to deal with that, so we would be creating another problem. And then there's also a big concern with the risk of contamination of recycling waste streams. A lot of the processors are already using compactors or mobile compacting services, but if they had an alternative box in use alongside the EPS and there was any contamination, that recycling process wouldn't be viable. So there's a number of considerations, but overall, it was quite good. So thank you for your time.
Thank you, Groina. Now, along the process, we challenged creative communities twice to help us come up with solutions, better options. One of them was we devised some, with the Aveiro Design Factory, we devised some hackathons with designers from several countries for several days. We put them inside a room, closed the doors, and for 2 days, well, more or less, and asked them to come up with solutions. We'll talk about one, which is there, which came up, which we took up. But there was another way of challenging the creative communities, which was done by Sociedade Ponte Verde here in Portugal, with a contest for new ideas. And João Letras will tell you what happened.
Thank you very much, Sandra. This is going to be a first for me, a presentation with the mirror ball spinning, so I think it's the first for... How cool is that?
You can dance
Come on.
if you want.
Okay, so I'll be addressing the issue of the contest. We wanted to do within Oceanwise, promote a contest of ideas and solutions to see if we could challenge researchers, industry, to come up with new ways of addressing the topic of EPS. And so I'll be addressing the reasons for our involvement in this contest, and also how did we get about setting this up, and how did this progress, finding the project winner, and what kind of disclosure and dissemination of the information was carried out to promote this solution that was the winner then, recognized by all. So we are the leading, as SPV, we are the leading packaging recovery organization in Portugal. Probably the only PRO in Europe dealing with domestic EPS. So we send to recycling every year close to 400 tons of EPS only from domestic origin. Most of this EPS ends up in applications for building and construction, so the blue foam for insulation. And it's a success story because it's possible within the yellow bin and in drop-off centers to collect these types of packaging items from small appliances and other types of packaging. EPS is not so common in the household. We know and we recognize, as has been mentioned here today by several speakers, that EPS is a fantastic material with excellent properties, very difficult to replace because it's cheap, it's light, it's very good properties. And so we encourage very much the promotion of best practices and measures to manage EPS as best as possible, not only in reuse practices, but also when it becomes in its end of use phase to get recycled. So with all of this in mind, then within the Oceanwise project, we developed this contest. And so this challenge was included in work package 4, with the prize money given by Ciudad Ponte Verde of 25,000 euros. And all the 5 countries involved in the project participated. We had 17 applications. After carefully reviewing all the applications, we did a not so short list, but we thought that 9 were very, very interesting. And so we took 9 of them to a final stage. And so we had 2 projects for communication and awareness initiatives, 2 research and development projects, 2 alternative fish boxes, 2 alternative plastic solutions, and 1 solution for plastics collection in the sea. Ultimately, the winner was Cyclic by Storopac, which was already mentioned here by 2 previous speakers, so a conjunction of 2 bio-based polymers in having a fish box that was industrially compostable and available in the market. So we thought it was a very interesting approach, and it was agreed within the voting of all partners that this was the best application, and so they won the project. Unfortunately, as it happens with many pioneers, we realized the market wasn't so ready to receive this yet, and so this solution is no longer readily available, but it can become available again if we see a market shift that demands this type of solution. So we promoted all the applications, and in the end, in the World Ocean Day, we did the closing of the Ocean's Calling, which was the name of the contest. Also, a podcast was created to promote and to disclose all the information, to disseminate all the information on the contest. And Cyclic was also present at the Portuguese Plastic Pack for the Ellen MacArthur Foundation. And we also had several news come in specialized media on this topic. To promote the contest, we devised a video that had a very big impact in terms of media and with all the people that we know saw it and addressed it with us. And so we have this video to show you, which was created specifically for the contest.
Conseguem ouvir-me? Isto sou eu a chamar-vos. Podem ouvir-me em cada espécie, em cada tempestade, numa só gota, em 70% da superfície do planeta. Chamo-vos porque preciso de vocês. Preciso das vossas ideias para salvar a minha vida, ou melhor, a nossa vida. Porque se é verdade que tudo começou comigo, também é certo que tudo volta para mim. Por acaso sabem o que acontece às embalagens que não são separadas e deixadas no ecoponto? Eu sei, porque aprendi da pior maneira. É aqui que elas vêm parar. Sim, eu sempre partilhei tudo convosco. O que vos peço agora é que me protejam. Reciclem. Partilhem as vossas ideias para reduzir o impacto das embalagens e de tudo o que não faz parte da minha natureza. Eu estou aqui, onde sempre estive. E vocês estão aí.
Okay, so this was basically it. The contest was a success. We were able to engage with lots of other players and actors and enterprises. So it was very useful to bring the message of EPS waste management to other parts of the economy that normally don't address these types of issues. And we were very happy to be able to award Storopac the prize for their innovation. Thank you very much.
Thank you, João. And so, well, we come now to the part that we like the most, which is our set of solutions, our set of recommendations. Of course, we've started talking a little bit about them as we were presenting the first parts of the project. And so, first of all, I would ask you, Camille, you've opened the door a little bit about that. Of course, in the process, we ended up developing a marine impact assessment toolkit, because we do think that what we did understand, of course, is that when we look at impact assessment, the marine environment is not so often considered in the full extension that it needs And so this is a version 1.0 of the toolkit, but we think this is we're very proud of this work. We think this is a very important result and a tool that we really want to see it being taken up in the process of considering the marine environment when we're thinking about environmental pollution. So Camille, please.
Hi again. So yeah, I have shown you before with the two presentation that impacts of plastics, and especially EPS, XPS, and alternatives are complex, because there can be very different impacts on the marine environment, and I'm only here talking about environmental impacts. So what we wanted to do in the context of the project is try to develop an approach and a toolkit of methodology to assess a global impact of a plastic material in case of it reaches the marine environment. The idea here is to help decision maker by trying to predict, or at least providing data to predict the potential global impact of plastic likely to reach the marine environment. So to do so, we perform a review of plastic environmental impacts, and we try to identify as much as possible all existing assays that could be applied to assess plastic, and especially EPS and XPS and alternatives, impact on the marine environment. And based on these assays identified, we elaborate an approach to combine the result obtained in order to gain a score, trying to reflect the impact of each material. Once we have developed this approach, we perform a case study on 3 EPS and XPS and 3 bio-based and biodegradable or compostable alternatives, which were actually the one I presented before, in order to compare the global impact of these alternatives compared to the conventional EPS and XPS. Regarding the development of the toolkit and the associated approach, we categorize the impact of plastic in the marine environment in 3 main categories. The first one was the weathering, and in this category we consider the colonization by either fauna or flora, and also the degradation leading to release of particles like microplastics, for example. We also consider a second category, which is the transfer of hazardous chemicals in the marine environment, and the last and third category was the toxicity on marine organisms. Considering these 3 different categories of impacts, we then perform a review of all existing assays based on standards, protocol, and also based on research work. And we identified 48 assays that we that could be used to evaluate impacts of plastic material, and especially EPS and XPS, on the marine environment. Among these assays, we found protocols allowing to assess material colonization, also material persistence on the coastline, also quantification of chemicals, leaching in seawater, and traducing the transfer of contaminant in the ocean. We also found standards allowing to assess endocrine description, toxicity, etc. Once we have collected all this information, all this protocol, we developed a preliminary approach to combine the result obtained and to provide an assessment and a quantification of the potential impacts. Our idea, our proposal was first to select a minimal number of assays in each impact categories, and we proposed to select 3 in each impact category, 3 assays to perform. We also need, for the moment, to have at least 2 materials, because for the moment, a lot of assays do not have any threshold value or standards or environmental norms allowing to assess if there is an impact or not. So we have to compare 2 materials to obtain relative results. Once we have the selection of assays and the material selected, we have to conduct the assays on the 2 materials. And we then, based on the result obtained, attribute a score for each material, depending on the intensity of the results. The score for each assay are then combined to obtain a global score for each material, and then, based on this score, we can interpret the result in terms of impact and rank the material, knowing that the lower the score, the lower the potential global impact. So this is our proposal. We then tested it in our case study on the 3 EPS and XPS products selected in our study, and also on the 3 alternatives. And you have here on the table the result obtained for the 3 impact category and the global impact score calculated as a result. And you can see that for the 3 EPS and XPS, we have higher score between 2 and 2.6 compared to the alternatives, which have a score between 1 and 1.1. So this is only a first trial to obtain this type of assessment, this type of global impact assessment. However, we can observe that results obtained suggest a higher potential impact of foam polystyrene compared to alternatives. And based on this result, it can suggest that replacement by selected alternatives could be environmentally relevant. So this is an illustration or attempt to provide an approach to assess the global impact of plastic material to likely to reach the marine environment. However, it must be noted that it's only a first step. For the moment, the approach has a number of limitations which are related to knowledge gaps and also methodological gaps. So for the moment, results have to be considered with caution, and more development are now needed to improve and go further in the development. For example, the quality is, I don't know why is all mixed up, but more development are needed to obtain first more standardized protocol to assess the different impacts. We also need threshold to assess the level of impact, and also go further in the calculation of the impact score to make it more robust and more environmentally relevant. Thank you very much.
Thank you, Camille. Then another product that we have to show you has been developed by our partner in Spain, Sustain. This is the circularity methodology. Unfortunately, Carlos Leon and Rebecca could not be here for the final presentation, as the little baby was just born. And so what we have asked him is to send us a 5-minute video that is the shortest possible version we can do of the circularity methodology. It can be, if you are not in the field, it is very specific, but on the other hand, of course, if this is your field of your line of work, what we invite you is to go through the extensive reports, and the 3 reports that come up that explain the circular methodology that we have developed. But for today, what we have is a 5-minute short video that introduces you to the methodology we have developed. This is a methodology for circularity and sustainability, and yes, and we'll show you the video.
Hi there. I'm sorry I couldn't be able to be there with all of you sharing the results of the project, and today I'm going to summarize the main aspects of the methodology for the circularity and sustainability assessment of EPS and XPS products and applications. During the project, we have been leading work package 6, circularity indicators and tools, trying to develop circular economy-oriented methodologies to analyze the circularity of current and future solutions for those materials, trying to respond to Oceanwise main challenges from marine litter perspective and from circular economy perspective as well. During the work package, we have been working in 3 main deliverables, and in the first place, we work in activity first, and the first activity and the second were related to perform a state-of-the-art review of, in the first place, circularity assessment methodology for those materials or plastic products or for generic products as well. In the second activity, state-of-the-art review related to methodologies for the design for circularity and sustainability. And finally, this methodology. So the aim of this is to guide the assessment of circularity and sustainability of the life cycle of EPS and XPS products and applications applicable to both current and future potential alternative solutions. By solution, we are not talking about just the material. We mean solution, a combination of possible alternatives throughout the life cycle. So using a specific material, a particular manufacturing process, different distribution processes, waste collection systems, and end-of-life management processes. So we have conceived the methodology in 5 different steps, starting from the value stream mapping, identifying all the operations all along the life cycle of the product, in order to identify and quantify the raw materials consumed and resources consumed in every operation, so as well as different waste generated. The steps 2 and 3, step 2 is about circularity assessment, selecting in the first place circularity indicators aligned to the circular economy principles. And in the step 3, the sustainability assessment, we start doing individual assessments related to the 3 dimensions of sustainability. So life cycle assessment to analyze environmental impacts, and life cycle cost assessment in order to know the cumulative cost along the life cycle, and eventually the social impact of the life cycle. With this, we can select the sustainability indicators in these 3 different dimensions, and finally the methodology is guiding to obtain an overall sustainability score. Step 4 is about combining circularity and sustainability assessment in order to identify the critical parameters related to circularity and sustainability, and then how to perform a sensitivity analysis against those critical parameters, and finally try to identify risks and opportunities related to circularity and sustainability, thinking about the legislation trends, market trends, technology trends, availability of raw materials. And finally, we propose how the methodology is guiding to perform trade-off analysis, consider different kind of scenarios for the same solutions, for example, different distribution processes, and to compare different alternatives solutions throughout the life cycle. And finally, we have studied different stakeholders around the project, so we developed the methodology in order to be useful for the different stakeholders and try to add value to them, because they have different needs and expectations, of course. So we have considered how to add value to research centers, raw material suppliers, products industry, users, waste management companies, and recycling companies mainly. And well, it was quick. Thank you very much for your attention. And well, the deliverable will be available soon in the website. Bye-bye. Thank you very much.
Okay, and now on a completely different line of Oceanwise projects, now we're becoming real. We told you we closed a bunch of designers in the room for 2 days, and we asked them to find solutions. We put in some mentors, some technical mentors from the industry and from in the room as well, and they came up with several solutions which are very interesting, and I invite you to read the designers hackathon's report from the website. But one of the products that we thought was particularly interesting and which can be of use, and we asked them to actually produce, or we sponsored its production, is what we're calling the EPS slicer. I'm going to ask Alexandre Comagai from the design factory in Aveiro to show you how it works. But what the EPS slicer does is it creates a solution for one problem, which we've talked over and over again here. The EPS is made essentially of air, so 90% air. It's great in terms of consumption of raw material, but once it is discarded, like a fish box which is used once, and then it is no longer a product, and it needs to be uptaken it needs to be recycled, then it has a problem, which is it is too much air, it has no value. If you transport basically 90% air and a little bit of product, it is economically and environmentally not the best option. So of course, compacting, densifying EPS on site where it is produced is something that we are advocating over and over again for a solution. If you know that if you have use of EPS in one place that is disposed regularly, like in a fish market, like in other places, and it is discarded there, then it needs to be taken for recycling. Then of course, having something that reduces the volume before it is taken for recycling increases the value of the product, of the wasted material, and it can be taken up by companies that do recycling. A compactor is one thing, but what we have thought of as an alternative to a compactor when it's perhaps too much to have a compactor is something that simply shreds. It cuts the box, a fish box, for example, in smaller bits, so it can be packed with a smaller volume to be taken up. And so this version of the EPS slicer, it works with a
so it works with a battery. either with the battery or connect to the plug it to the electricity. And we have these two options. And we started building very industrial one, but we came up with the idea that we should do something very simple and more accessible to everyone that can be done easily. So this particular model, we do the ads, and I think we can make it without just plug it with the electricity for a cost of more or less 400 euros. And if we have the batteries, it's another 300 euros. The battery is the major cost. But we think this is with this cost, is a very affordable, and it can be done in the markets easily.
So what we're also doing is that the instructions, the developer's manual is open for, it's on open source. We're publishing so that anyone can pick up and take it. The other thing is that it can be put on wheels and it can be used, for example, in the market. You can easily take it around. And can you show us how it works? Basically, what we have is a grid, a metal grid that is electrified. Of course, yeah. What it does is to break the box into much smaller bits, because what we knew was that we saw when these fish boxes are discarded. A lot of times you have the recyclers asking for them to be broken into little bits so that they can take them, but of course at the place where they are discarded, they don't have the time to do this, so it becomes a problem. The grid is very wide, so that only a little bit of the EPS is burnt. Yes. Well, the smoke is not the most desirable solution, of course. We are burning a little bit of EPS, but what we have here is an option for EPS to be taken back to recyclers, or otherwise being discarded because nobody wants this.
And without any bits lost, so it's a clean cut.
Yeah. Yeah. So, thank you.
Thank you.
So we have shown you a few solutions, but I would ask Maeve Thornberry if you can sum up the set of solutions.
So we're kind of at the end here, and I always like a visualization. So this is what we're talking about, folks. Always good to have to remind ourselves, what was the point of the project? It didn't throw itself there. Material doesn't throw itself into the marine environment. We put it there. We're responsible for it ending up in the marine environment. And I think that's something we really need to remember. EPS, XPS, it's not evil. It's just we're really bad at disposing of it. And we need to figure out better ways of disposing of it, better ways of managing it, better ways of trying to make sure that somebody doesn't just, throw it away. Sorry, I'll need a slide. So the Department of Housing, Local Government and Heritage commissioned me to do quite a lot of work. I did a lot of work on policies, which we haven't covered today. And then they asked me to also cover the final report. And that's effectively pulling all of this information together, because again, it goes back to what I said initially. It's really important that stakeholders, people who have an interest, people in industry, municipalities, recyclers, waste management companies, have something concrete that they can take away from this project. one of the main findings, and something that Oceanwise hopefully has done, is identify those gaps. And there was massive gaps in terms of data. I rooted around. I've spent 3 years on and off on this project. It's been a fascinating project to research, but boy, did it take a lot of work. So it's just because there was very little data. Sometimes you're looking for data that's commercially sensitive. I wouldn't expect any private company to tell me how much EPS they make and put on the market. That's fair enough. So then you're reliant on trade organizations and trends and overall statistics. So hopefully something we've done is plug some of the gaps. And what became apparent throughout this whole project, and I found it, and I know my colleagues and all of the other partners found it as well, if I had €5 for every time styrofoam was mentioned incorrectly, I could have flown here by private jet. It's everywhere. Everybody uses styrofoam. Styrofoam is not XPS. It is a trade name to describe a product made by the Dow Chemical Company. How it became part of the vernacular in places in America, in the Caribbean, in certain parts in the Pacific, I have no idea. But it is there, and it does cause a problem because people talk about styrofoam when they actually mean XPS, or sometimes EPS. So that really is, that has been a very big, that was one of the main findings, is that cropped up all of the time. And sometimes you feel companies and municipalities are doing fantastic work, and they're not shouting from the rooftops about it. I went to Billingsgate Fish Market in London. They are processing somewhere between 900,000 and 1 million fish boxes every single year. And yet, if you go to their website, there's like one sentence about that amazing work. It gets compacted on site, it provides jobs, it gets transported abroad, and it gets recycled. And yet they don't have that as a big, huge thing on their website about how great that is. And then another, and I mean, we're just picking out, obviously there was lots of findings, but these are just some of the key ones. It's so difficult to figure out where that EPS and XPS that Camille and Osmar and people are finding, it's so difficult to try to figure out where did it come from? Where did that start off? There's a really good chance that if I find a piece of EPS on the west coast of Ireland, that it came from somewhere in the Caribbean and came the whole way across. This is a transboundary issue. And yet, I'm not sure that there's been a phenomenal amount of transboundary kind of communication or collaboration. At this point, I will juncture, if anybody wants me to go to the Caribbean to work on this with them, I'm happy to volunteer. We know there's alternatives. There's quite a few of them out there. Some of them work really well, some work better than others. They're not necessarily less harmful to the environment. And ultimately, is it better if something that biodegrades or composts is thrown into the marine environment? That's a difficult one. And then there's a lot of factors that affect the recycling of both EPS and XPS. It's complex. It's not simple. It's not. There's a lot of reasons why EPS and XPS don't get recycled or as much as they could be. So, some of what we're suggesting. The SUP directive is a phenomenal piece of legislation, but ultimately, if you put in EPS, single use, XPS, single use, should be in there too. It's as damaging in the environment as EPS. And in fact, when you think about it, clamshells, those lidded containers for takeaway, they are so likely to end up in the marine environment, and they're always made from XPS. So that would be great to see when the SUP directive is reviewed come 2027. a more detailed and more nuanced list would be great to see. There's already great collaboration between industry, private sector, municipalities, waste management companies, but there needs to be more. And I would say specifically for end of life, for the waste management companies and the recyclers. Waste management companies are a mine of data. They're absolutely amazing. They know what comes in. They see what we throw out. They're a really valuable source of information, and it would be great to see more work done with them and being brought into that kind of stakeholder engagement, because I think they could help figure out how we fix some of these problems. There is no doubt EPS and XPS in certain applications shouldn't be allowed. If a EPS pontoon breaks up, that's a catastrophe for the marine environment, and we know that from the tests that our colleagues have shown us here today. So certain things really, you have to figure out what can we replace those applications with. There's definitely opportunities to recycle EPS, and I appreciate XPS is definitely more tricky. But EPS, there's companies doing it, but they possibly need more support, they need to get their message out there, and they need help in terms of scale. And then ultimately, if you capture all those fish boxes, say, and you capture all that household EPS, and you recycle it, where does it go? We need to legislate. If there's a legislative requirement that says you must use a certain percentage of recycled EPS or XPS in a product, then the demand is there. Then the recyclers are saying, oh my gosh, we can't find enough of this stuff. So that would be great to see, and that would be great to see developed. And ultimately, all of the findings, all the outputs, hopefully will help our policymakers make more informed decisions. It's really important that when we are making legislation, policies, bans, we need to be very clear about the uses and phrases, and that goes back to that styrofoam issue. If you mean EPS, talk EPS. If you mean XPS, then reference XPS, not a trade name. Ultimately, we need a lot more in terms of deposit return and other food system services that don't involve the use of single-use plastics at all. It was really frustrating to be in Dublin Airport on the way here, and every single cafe only served in single-use cups. So what, we don't wash cups anymore, and COVID's not a reason for that. So that's very frustrating, particularly in light of the SUP directive. So deposit return, encouragement to use reusable, I think there's definitely more work required there. Carlos's presentation on life cycle analysis. There's analysis out there, but it's kind of patchy. So he's obviously given fantastic example there of how it can be improved. Because if we are going to replace EPS and XPS with alternatives, you really need to know that they are actually an improvement and that we're not replacing one problem with another problem material. And that leads into that investment in alternatives. We need more research. What we've done really well, but there needs to be more of it, more analysis, more tests over possibly a longer term to determine, are these alternatives that we're saying we should, get rid of EPS, are the alternatives really any better? My takeaway for everybody watching is that we need to take action now, folks. You can wait for the policy, you can wait for the piece of legislation. Don't wait. Oceanwise is up and running. We have tons of material. There's lots there, depending on what you're interested in, depending on what kind of stakeholder you are. There is a ton of information that wasn't available 3 years ago. It's available now. Don't wait. Read the case studies. Read about the areas that are interested of you and figure out and say, yeah, I can do something about this, because we have no time to lose. There is so much going on with climate change and everything, and marine litter is a huge problem. So if there's stuff that we can do that improves that situation in any way, shape or form, then we really should go out there and do it. Obrigado.
Thank you very much, Maeve, for setting the ambition, telling you what our ambition is for. And so finally, before we break for 5 minutes before the round table, I would ask Anna Pirish. She has been with Oceanwise at the initial phases from Nova University, but then she moved on to work in the industry and also promoting more circular solutions. And we have asked Anna Pirish and her team to put together 2 pieces of communication very dedicated to specific audiences. So we have one brochure that you have with you that is aimed at policymakers. And this is a set of aims, solutions, proposals, ideas that we have and that we'd like to see taken up. And we have also produced another one which is more aimed at industry with best practices. That was our aim at the beginning back in 2018 when we started. And these 2 brochures we hope will be useful for taking up Oceanwise solutions. And I would ask you to summarize them, well, briefly.
Yeah, completely briefly. Thank you so much for being here today, for your invitation. And so I'm going to start my presentation explaining what is the importance of making all the dissemination and exploitation of results. We see today a lot of information, a lot of data, a lot of knowledge that if we do not put it in a correct way to all the stakeholders to understand it and to assimilate it and make the right decisions concerning EPS and XPS, probably we are not going to have the effect that the project intended to. That was to reduce the environmental impact of EPS and XPS on the environment. And so, in one hand, we need to share that information with a lot of the potential users that we have here. So we have the EPS and XPS producers, we have everyone that makes products of that material, the consumers, of course, and also the waste managers. On the other hand, we need to use these results to help the policymakers to make better laws, better rules, better market-based instruments, and wherever that it's needed to make the EPS and XPS stay on the technosphere and not to go to the environment. And so that was our main goal. And so we have here the two documents, if you can say that way, to help, in one hand, the best practices guide for all the stakeholders that can or deal with somehow with the EPS, XPS, and also a policy brief that we hope we can reach the policymakers to make better policy rules and instruments to control the life cycle of the EPS and XPS. So in terms of the best practice guide that we've made, altogether, of course, all the inputs from the Oceanwise project, what we think that was more easy to be understood by the stakeholders was something more clean and focused on the best practice that was already obtained through the project. So we characterize in the background of that best practice, what is the action to make, an example or several examples of that best practice, and then all the constraints that we have to deal with to implement that best practice, okay? So it was more or less what we have tried to do, at least at this version. And so this is a collection of everything that you can see on that brochure that you have. And so basically we have best practice related to the substitution of EPS and XPS for another material that can be a plastic or can be a bioplastic or biodegradable, etc. But all the recommendations that we need to take care of before making that substitution, we have to consider it. And so we have put it on the guide. Of course, the design for durability. We can use EPS and XPS, of course, but we have to design it in some way that is not going to get broken in the environment, etc. And so we can make that kind of design.
Of course, that we have to support our decisions through methodologies. Today we talk a lot about risk management and assessment of environmental impacts, and also the life cycle assessment and circularity assessment. All those methodologies are useful to make a more reliable and a more environmental, if you can say that way, decision. And of course, we talk about how we can put the EPS and XPS again and recycle it, and we need to make collection systems, waste collection systems, reverse logistics systems that, at least in Portugal, they are not so common, but in other countries they are. And so we have to think what we need to do, how we can make this kind of schemes, and what we need to implement them. In terms of the policy brief, we are a little more further because we would try to see how we can make changes on the SUP directive, because it's going to be a revision of this legal document. And so we focused specifically how we can improve SUP directive and answer to the goal of the directive and Oceanwise project, reduce environmental impacts from EPS and XPS. And so our policy brief was focused on these 6 points, and these 6 pillars. So we are trying to improve in terms of the legislation concerning the identification of this kind of material and the monitoring that we need to do. The measures that have to be implemented concerning the life cycle management of these materials, safe and sustainable by design criteria that are quite important to make the material less with lower negative impacts, standardization of the methods, which kind of financing we should ensure to make those assessments, those methods to be on the market fast enough, and of course voluntary agreements and information instruments that can be promoted by SUP directive. If you look to the brochure, that I'm not putting everything here because it's quite big, but it's not that big, so you can read it, okay? So don't be afraid. I'm just going to highlight here some points. So basically what we have in terms of identification, and Mavet talked about that, we really need to make a definition. We try to make one focusing on foamed plastics because we are afraid that if we always specify the polymer, the market change the polymer and they keep with a foamed plastic. And so we need to focus on the properties and in the origin. So we have to make probably a definition for foamed plastics, and the plastics is already defined in the SUP directive. We just have to put it the foamed property. In terms of the life cycle management, of course, that we have to define the rules. EPS and XPS are great materials, everybody agrees with it, especially in the construction. But there are other uses that we have to probably not allowed that use or forbidden or limits that kind of use. And we have also a proposal for that. In terms of the safe and sustainability by design criteria, this is an intention of the chemical strategy. And so we really need to consider it when we are producing the polymers, not only the EPS and XPS, but also the polymers that we intend to replace, or every polymer that we intend to put on the market. You must be sure that their use, they are made with additives, they are not going to be harmful for us, not the environment. And they also have some proposals concerning this. Of course, we need better standards concerning the biodegradability, the compostability, etc. And of course, everything needs some money to get a little faster on the market. And so we're also proposing some kind of policies to make the financing of the assessment, the risk assessment, improve the life cycle management assessment, because LCA is not capable to assess the impact of microplastics, to have this idea. And so when everybody wants to use LCA, be aware that it's not a complete solution to assess environmental impact. It's great, but it's not capable to measure yet microplastics impact. And so we still need other kind of tools, other kind of methodologies to assess it. And of course, the industry, the stakeholders, everybody can work together to implement voluntary information instruments to reach better what is the concerns about plastic, the microplastics, and everything that is related to plastic, that it's now a problem, and we hope that's going to be a solution, or the problem gets smaller in the next few years. This is also one screenshot of the brochure, where you can see the impact of some of the proposals in terms of the other policies that we have already in European Union and also in United Nations. Thank you so much.
Thank you so much. I don't know how you do it. You always seem to be able to summarize everything in a perfect way. Well, I hope you find these brochures useful to you. So we're having a 5-minute break, and before we have the final roundtable. Don't go away, because the roundtable has an incredible set of panelists to commentate on our results. Some are here and some are online. And of course, for those here, then we have a party waiting for you. So 5 minutes, and we start the roundtable. So do we have the other participants also online? Yes, they could. Yes, and here they are. So, well, first of all, welcome to you.
So, if I'm here, they cannot see them.
You can? Okay, so let me introduce you to our guests. We have John Mowat is the chair of the AIA committee at OSPAR. So where we grounding the initial stages of Oceanwise. Elisa Setien has been with us from the beginning. Elisa, when we started the project, we met first in 2019. Elisa was at the time the Director General of UMEPS, which is the European Association for the Producers and Manufacturers of EPS, based in Brussels. She's no longer in the same position, but has been with us all along and helping us shape the project. And Inês Costa from Portugal is currently at Deloitte as a consultant, but when we started the project was designing and launching the Portuguese action plan for circular economy, and was then Secretary of State for the Environment in the Environment Ministry. And so for the three of you, welcome, and thank you for being here. I'm going to start with you, Elisa. You've seen the evolution of the project from the beginning, and I remember when we first talked back in 2019, and we met in one of the stakeholders meetings in London, and I had to convince
Dublin.
you. In Dublin, okay, sorry. And I had to convince you that we were a reasonable and moderate forum worth listening to, because of course all the industry believed that we were here to ban EPS, and I told you, no, we're here to prevent that EPS reaches the sea. Maybe in 3 years' time we'll be telling you that we want EPS out of the market completely, and we'll be strong advocates. But you've seen how the project has evolved. How do you think now that we're coming to the end, is it useful?
Well, it has evolved a lot, and I would say in a positive direction. It's true that at the beginning of today, you have said there were some stakeholders saying, "Why are you focusing on EPS?" So I was one of those stakeholders. I still think that EPS has been targeted, maybe not for the good reasons. But I still think that we have a common goal, and that's something that was clear then in 2018, 2019, and it's still clear today. None of us wants to see EPS in marine litter. That's as clear as it gets. And we have, in the industry, we believe that we have potential for additional recycling. I still believe that EPS is a material that is highly recyclable and it's widely recycled. Could we do better? Sure. But it's in our best interest that EPS does not come into marine litter. Having said that, I still think that I do not agree with the recommendations you have done with the SUP today. But mostly I think the project has advanced in a lot of directions. I think it's extremely positive that the statistics of the OSPAR are separating EPS, or at least making its best to try to separate EPS and XPS more and more from different plastics or from this mixed collection of plastics that it was at the beginning. I think it's also positive that you are openly discussing about the environmental impact of EPS, that as we have seen today, well, we don't seem to generate toxicity or significant toxicity in the seawater. That's I think it's a nice discovery or a nice finding of this project. Industry is always looking for alternatives. So I think that the fact that the project has also dig into that is positive. I personally, have a small. So close to my heart is the hackathons and all the activities that have been done to try to promote EPS and to try to have these oceans calling with new products, alternatives, new ideas, as the EPS slicer that the Aveiro colleagues have presented today. I think those are aspects of this project that I did not see then in 2018, 2019. But I'm glad that they have been developed through the project.
Okay, thank you. But do you think the project will be useful for the industry to take up the recommendations?
I am sure some of the recommendations could be taken up, but I'm afraid we are going to challenge some of the others, even if I'm not in the EPS industry anymore.
Okay.
I can predict that very clearly.
Yes. Okay, thank you. Then, John, you have been there from the beginning when we first started the project. Now, of course, OSPAR has evolved to a new regional action plan, which includes, of course, the Oceanwise results in there. How do you think the project results will be useful?
Yeah, thank you very much. And firstly, sorry for not being with you there in person today. I would like to have been there, but I think that I'm really impressed with the outcomes of the project. And I think, as Michael said at the start, having that clear link in through to how the project results can impact on policy will be useful. Obviously, as you mentioned at the start, this was kicked off by the first regional action plan that OSPAR took on marine litter, and this summer we adopted a second regional action plan where we have now have quantitative targets to achieve for reduction of single-use plastics, working alongside the Single-Use Plastics Directive. But there's also specific actions in there looking at how we can pick up the results from this project and particularly apply them across OSPAR. And I think therefore, the products where we're looking at information for policymakers will be very helpful in how we can take that forward and hopefully look and see where OSPAR can add value. Obviously, there's spreading it through the European directive is a way to reach a wider reach in terms of some of the actions, but OSPAR obviously brings in countries that are not members of the EU anymore, possibly. And we need to see where those added values can be, and particularly looking at some of the marine products where OSPAR can perhaps take quicker action than 2027. So we're looking forward to seeing the results feeding into the development of that particular action under our regional action plan on EPS and XPS.
Yeah, thank you. Michael, I would ask you the same, of course. How do you think the Oceanwise project will be useful from the viewpoint of the Commission?
Thank you. Well, I have to say that I learned a lot today. Of course, I knew what the project's about and had read some reports, but really I understood today much better what you did and why. And if I may, I think it's understandable that I come from the marine environment point of view, so I was more interested, so to speak. Of course, everything was interesting, but I was more interested on the analysis of the impacts on the marine environment, of the material, and also of the alternative materials. And I think it's because you know that identifying the impact of a material on the marine environment or of a pressure, so to speak, is a very complicated issue to identify impact on species and habitats. But now what you did, if I understood it correctly at least, is that instead of trying to find the perfect methodology, you focused on a material, you identified some impact criteria, so to speak, and then you applied the same criteria to the substance and to alternatives, which is, let's say, brings us away from, let's say, seeking the absolute best methodology of what is the impact and how. No, we compare the impacts of various materials, and for this specific material, this is, I found quite interesting and original in your project, focusing on a material from all points of view. So for this specific material, which is problematic for the marine environment, we know, but to which extent, why, and how can we reduce the problematic aspects? So these were adequately covered, and now we know, for example, I mean, improvisingly, we know that there's no need, so to speak, from the marine environment point of view to ban EPS, but we must ban the buoys or the other application I forgot. Huh? So these two, for example, for these two cases, it should no longer be used, full stop. And we also know that PLA, for example, is not necessarily much better. So from the marine environment point of view. So these are the aspects that I found interesting.
Mikael, we also, when we started the project focusing on EPS and XPS, we've always said that the project is intended also to provide a benchmark for future work done on the same approach, trying to bring the concern for marine environment, the risk and potential risks of plastics to other, about other materials, of course. We don't have any obsession with EPS or XPS. We took this problem on board, but we've always looked at it as a potential benchmark that could be used for other projects. And so, of course, this is something that we, Oceanwise closes with the recommendations that we have for these materials, but we see it as a proposal also that can be taken up in future work. And Inês Costa, you are on that balance between the marine environment, of course, but then of course the circular economy and from other perspective is your field. How do you see this and the usefulness of this project?
No, first of all, thank you for the invitation to be here to comment. I've been following the Oceanwise project for quite some time in my past life as an aide for circular economy with the minister and also as a Secretary of State for Environment. I think that Oceanwise was a very successful project in the way that it bridged a gap that still exists today between what are our wants and what we actually do. So without any, second thinking, without any, hidden agendas, Oceanwise basically very plainly said, look, we want to find what is the impact of these materials on the marine environment, what can be viable substitutions. Let us think this in a systems approach way. So there is the value in the approach that Oceanwise provided as a tool by itself with all the hackathons, etc., is also valuable as a deliverable to be replicated in other types of materials. So that's one approach. I think that it also it serves us as a reminder that we are still very far away of being actually committed with the flagship ambition delivered by the European Commission and even at the international level. Let me remind you that tomorrow the European Commission is due to propose a new law to tackle packaging waste. There was a lot of information going on in the past few weeks about it, with mixed feelings about it. The industry was very remanent in pushing back the ambition thrown out by the European Commission. I understand that today there were all sorts of news about diluting the ambition on the aspect of, for example, for reuse, which is absolutely fundamental to really achieve the circularity in plastics that we want. And at the same time, we are having a meeting, UN global meeting in Uruguay right now to discuss a global plastics treaty. So these are pieces of the jigsaw puzzle, within which Oceanwise is part of, more than you can at first think of, that really connect the dots between, yes, there are ambitious goals. We know that they are probably not feasible in a calendar that is settled, but we really want to, okay, what can we do right now to be put on that path towards achieving those objectives? We cannot, in this particular case of plastic pollution, demands are going to be higher from the European Commission, and not only through directives such as Packaging Waste Directive. Other directives are already pushing for evidences of what companies and businesses, like in the fishing industry and others, of what they are doing in terms of reducing their exposure to plastic pollution. For instance, in the Corporate Sustainability Reporting Directive that was also approved this week, or the regulation on eco-design, these are issues that are going to be central to business competitiveness in the short term to medium term. So projects like Oceanwise provide evidence that yes, it is possible to do it. It is possible to creatively, and in together we can creatively develop solutions, and not only to these particular types of plastic CPS, but also we can perhaps do it to other types of materials as well.
Yes, thank you. And Anna, you are now working directly with the industry and advising the industry. How do you see the usefulness of a project like Oceanwise?
Well, I think the industry, it's not used to have this kind of participation or collaborative process, and to use that kind of process to make changes in their industry. All the stakeholders platform, the Dialogue Living Labs made, they are quite innovative for the industry. They are not used to think and look to the other players as a partner, but more like a competitor. If the Oceanwise is capable to show that everybody together, without having problems with showing their failures or their disadvantages on the market, if everybody puts the cards on the table, probably they're going to work on measures and explain to the policymakers the help that they need to make the changes. But this kind of process, it takes a long time, but it's more useful than just make the policymaker make a law, and like was the case of the plastic bags in Portugal. It was not completely with the industry, and some industries, they have to close down because the policy enters before the industry was capable to make the change. And I think that the Oceanwise can make the opposite. With this, during 3-4 years, they were talking with the industry, talking with the recyclers, and explain the importance to deal with the problem. Now the industry understands that they have to make something to change, because more one day, less day, they're going to have that kind of rules of that legal documents are going to make them make that new innovation or that measure, and they're going to have the risk of closing down if they don't do something. And I think that this kind of project, if the industry understands their role, they can play and they can get advantage to make the changes that they need to face this problem.
Okay. How do you see? Okay. Next steps. How do we? What in the short term? What is your recommendation for how to take it up? How to go about it?
To involve the industry.
Yes.
You have to put the industry and the policymakers together. These two elements, they have to be together, because when they understand the market works perfectly, it's no problem. But the market, it's not obvious who is the client sometimes. When I produce EPS, I don't know who is going to be the user at the end, right? More or less. But if I make a construction material, I know who is my client. But if I only work with my clients, it's not going to be enough, because my clients do not understand the problem. And so if I have the industry, the policymaker, maybe some NGO, but sometimes they are not very well known by the industry, but the customer, the user. You put these three together and working together to make the policy, the public policy, you can make the change. So I think that this is the next step. I don't know if it's through Environmental Portuguese Agency and the other agencies in Europe, but this has to be a collaborative process. If it's only the policymaker to make the rule, the industry is not going to make the change just like this. But I think that we have to put all the three on the table and say, we intend to put this kind of rules. Do you agree what you are intending to do? And reach a compromise solution. And this has to be done really, really fast.
Okay, Elisa, would you agree with this pathway?
I like this idea of not having a top-down approach and to have a more collaborative and open process. I also believe that this project has shown, I think quite clearly, that also the Commission and the authorities, they work in silos, and that nevertheless things go together. So this is not a DG Environment or DG Energy or DG, Industry problem. That goes together. And that's not always the case. For example, in the Packaging and Packaging Waste Directive that's going to be published tomorrow, it's for sure that they haven't considered the marine litter aspect of the products. So, and that's a reality also of how the law is being done. So definitely working together and talking together would be a good step forward.
Mikhail, do you think projects like Oceanwise can be? What do we need more to do to help you to get all the silos, as Elisa is calling them, together? Of course, we have talked also with other teams in the Commission, and you have been our main connection, of course, being the representative that is OSPAR. Of course, we have you bring in the plastics strategy and the Green Deal and the action plan to us, of course. But what are the next steps? How can we help more, other than delivering you the project?
Well, I think there are two aspects. One in terms of knowledge acquisition and knowledge which has been created and put together by this project. This is one thing. And the second thing is the interaction with stakeholders. And both are very important for developing and for updating legislation. There was, I don't remember anymore who mentioned the revision of the review of the Single-Use Plastics Directive, which will take place soon. We had recently the review of the Packaging Directive, which is a very old one. If I remember well, it's from '94. And it's not the first revision of the Packaging Directive. So the legislation is constantly updated, and two things, at least two, are very essential. First, take into account the latest knowledge, and second, take into account the views of all the stakeholders, of industry, of course, but not only of industry, because each stakeholder has their own, how shall I say, perspective, and it is necessary to consider, an organization like the Commission or national administration which makes laws has to consider the social interest and all the societal aspects, not just one stakeholder. The economic, the environmental, the social aspects, and so on and so forth.
Ines, you are in the habit of bringing things forward, pushing them forward, and as you say, we have short-term mission to place in many forums. What are your recommendations for how do we go about it?
Let me react on what the previous speakers mentioned, Anna in particular. We have an issue here in Portugal, unfortunately. I'm not aware of how it is in other EU member countries, but we tend to descale the importance of the pipeline of regulations that come out of the European Commission. And we are sort of come late to the game in terms of their discussion and implementation. So all the work starts with a proposal, okay? And that proposal is discussed several times across the span of perhaps one to 2 years, where there are several forums open to stakeholders to discuss the proposals of the Commission or the proposals for reassessment of directives. And public participation of civil society and of business must be further amplified at that stage. In Portugal, I feel, at least in my role as Secretary of State, I could say that for me it was very, it left me a lot of anxiety to see certain directives coming into play in Portuguese context. So they're still usually, typically, on average, a 2-year span to transpose the directives into national law. And and we engaged with companies, we tried to, through the environmental agency, we engage with stakeholders. We make meetings to reflect and to provide evidence on the objectives of the directive. But still, just as the directive is about to be transposed into national law and national law coming into effect, it's when suddenly companies wake up and say, oh, we are not ready. Although this piece of legislation has been in discussion for over 4 years. So at least 4 years. So for me, my experience in public office has been quite, I'm sorry to say, sort of contrasting between wanting to present and to discuss a piece of regulation that was ambitious, purpose-driven, and not having enough feedback from on-the-ground companies in Portugal about their willingness to step up their game and develop solutions to meet those objectives. So in the case of plastics, we have wonderful interactions with the Plastic Pack Coalition, for example, who has been apart from Oceanwise project, of course, it's another example of how business, citizens, ONGs came together to discuss the implications of the Single-Use Plastic Directive, of all the changes into the Plastic Packaging Directive, and to try to effectively work on a platform that delivers very concrete objectives. In the end, every time we talk about, and let me just, clarify the elephant in the room, every time we talk about reducing the economy's exposure to plastic, to unnecessary plastic, disposable plastic, which is not, used for high-value purposes, such as, for instance, medical supplies, etc., there is always a backlash because we are talking about reducing consumption of a material. So there is always going to be backlash from the industry because they are always going to be threatened by it, threatened by objectives of reduce and reuse. So even recycling, you can see that recycling is sort of going into the direction of being sort of in a lock-in position in relation to recycling, to the point where industry says, well, look, recycling collecting schemes are not viable unless we have plastic in the system. So that's a sort of a context in which we have to work, which we certainly have to work at systems level. So business, organization, governments, and citizens as well. Otherwise, it will not be possible to achieve those goals.
John, on top of that, we have the issue of getting enterprises to be concerned about marine environment, about marine litter. We're hearing in their talk a lot of talking about marine litter. We used to be alone. Some 6, 7, 8 years ago, we felt like we were the only ones concerned with marine litter. But this is something that is reaching out to several fields and, of course, also to companies. But do you feel we're really reaching them? And of course, the new marine litter action plan is also aiming at that.
Yeah, I think there's definitely been a sea change in the approach to marine litter and understanding within various industries, particularly when we're talking about the fishing industry, agriculture, have really changed their view in terms of approaching litter and waste that enters into the marine environment. I think it's important that we continue with the monitoring work that OSPAR does, and it gives a very good base to look across the entire Northeast Atlantic region and really highlight the different types of materials and what we see in the environment. And it was obviously that data supported the development of the Single-Use Plastics Directive by really highlighting the types of items that we find in the environment and needed to be addressed. So I think the awareness is much higher there, and I can definitely see I think a role here for OSPAR in terms of taking the Oceanwise results and really focusing in on combining some of the actions that we have in the plan, looking at waste from agriculture and fisheries, and taking some of the ideas around taking a circular approach and looking at the complete supply chain and how we can deal with these products, bringing the suppliers and the end users together, and whether there's a role for OSPAR to developing measures, particularly in that way, to kind of standardise the approach across the different OSPAR countries in terms of how we're dealing with that, particularly where you have industries that work across several different countries. The more standardised we can make the approach, the better and easier that will be to work with industry and specific suppliers for products that work in the fishing industry as well. Has obviously been a focus of the project. So I think that awareness is increasing, and I think there's definitely an opportunity there within OSPAR to take forward some of the targeted measures that focus on products that we see in the marine environment. And I agree that EPS is not a bad substance. It's just we just need to cut out the leaks into the marine environment and make sure that it's part of that that it's recycled and remains in the circular economy.
Michael, we also saw when the SUP directive was launched, of course, the background for all the action being taken was that we were finding plastics in the ocean. Of course, that again is the way we're heading as in the UN process of negotiating for a plastic agreement, global plastic agreement. So, how much do you think that the marine litter is a key argument when we're reducing environmental problems linked to plastics these days?
I'm afraid it will remain an argument for years to come, because plastic will not disappear from the sea. And of course, as let's say the future treaty aims to do, it is necessary to address the upstream problems of design of plastic materials, design of plastic products, waste management on land, and so on. But we will never understand and we will never have effective measures unless we monitor litter on land, yes, of course, but in principle there should be no litter on land, and at sea, unless if we didn't have the monitoring data from the Marine Strategy Framework Directive and from the Regional Sea Conventions, we would never have the Single-Use Plastic Directive. If we don't have the data on the impact on the marine environment, I forgot, I omitted to mention this aspect because you asked me earlier, what do you think is the major contribution of this project and so on? To demonstrate the mechanisms and the extent of impact of plastics in the marine environment. This is an area where we still need a lot of efforts and a lot of, let's say, research and a lot of projects, if I may put it that way. Because unless we have this kind of information, we will not be able to put the regulatory thresholds on various categories of litter that we were discussing. We have the legal, let's say, mechanisms, but in order to use them effectively, we need to have the information, because we cannot just invent figures. And we need the monitoring data at sea in order to understand how the measures that we take on land reduce the impacts in the sea. So the two must remain together. That's what I think.
Ines, did you, in your talks with the industry, did you feel that this message was passing through, or?
I feel it that in terms of traceability, what I feel is that again, the industry, at least the industry that I have came into contact with, are keen on understanding more about their value chain and to be equipped with that data. But again, they are not really fully aware of what are the demands that are coming up very soon. For example, the Oceanwise project mentions very particularly the issue of plastic traceability and how important mechanisms such as the digital product passport will be to really consolidate that information and to really bring that traceability into something real, into something that can be used by people, by buyers to agencies such as the Portuguese Environment Agency. Again, I ask, are industries aware enough that there are these important regulations coming up in 2023 that actually demand to collect information across the value chain on the type of materials, who are the producers, where does the material comes from, and to encode that into a digital product passport in order to then supply that information to the European Commission. I'm finding very few people are really aware of that. And that is an issue that very quickly needs to be embedded into the operations of the industry. My experience right now, my very short experience right now in Deloitte, already I can see that there are areas in which it's already offerings being developed in terms of digital product passport management, data management, which might be fundamental for business in the near future. But these will not be, worth nothing if a company is not fully aware of what are the demands that they are going to be in the near future. And particular for issues such as EPS, and all the materials, packaging materials that go into the fishing industry, for example, this needs to be addressed. And so either through, clients in the end, even B2C or B2B, in the end, that are able to push for or to raise the awareness of their suppliers about these demands, because they are going to be pressed anyways to supply information on their value chain as well, the end clients. So I hope that that in the near future, more and more industries will become more aware of the necessities and the areas in which they need to look, such as the issue with the eco-design regulation and DPP.
Anna, the companies that you're working with that reach you, are they ready for the new product, digital product passport? I know we talked about this during at Oceanwise, but we also saw the passport as an opportunity, because of course if a product is more sustainable, the information will be there, and the discarded product, the waste can have more value if the right information is there, and it will help recyclers and everything. But how are the companies ready for this?
The Portuguese industry, in terms of the injection molding part, that it's the one that we work more, Cintiq works more, they are not the OEM, so they are not the producer of the product when it reaches the market. So they are a supplier of the Mercedes, BMW, etc. So the main frame of our industry is that. And so they are more or less thinking that they are not the focus of the eco-design for sustainable products, but the BMW, Mercedes, etc. And so they are more or less waiting, the typical Portuguese posture in terms of EU regulation. They are waiting to see if that is going to be mandatory for them to have the digital passport, or if they only have to provide information. But when we have to, Cintiq was one of the technical centers in Portugal that has to make or tried to make a recommendation when the regulation was in a process of public acceptance of recommendations, and Cintiq work on that with the industries. And basically what we thought that probably the industry need more time, because more of our companies, they are quite small. So they do not have to have an idea. The person that works on environmental is the one of the quality and the safety, right? It's the same person that do these three things on a company. So it's quite hard for them individually to look at a regulation so big as this, the eco-design for sustainable products, and try to figure it out what is going to be the consequence for them. So you do some kind of that work for them, but we do not understand completely which is their market, and so we don't understand alone which is going to be all the demands they're going to have, et cetera, et cetera. And so I think that they need some help, but they will not going to have the time, because the time is already there. And so companies they really have to talk and to reach the entities that can help them to make that road more faster, because I think that they are always waiting for something else.
Well, I hope we've helped you with some good arguments.
I hope so.
But and finally, Lisa, you have a broader view than that of Portugal. I hope the Portuguese companies are not the only ones.
No, I think companies in general are struggling because and I think associations in general also are, both national associations and European associations are trying to, first of all, map all the activities that are there, because while you think that it's only going to be the packaging and packaging waste directive tomorrow, that's not the case. So both construction product regulation and the eco-design revision were launched on the 30th of March. Tomorrow you're going to have the packaging and packaging waste. You're going to have one on green claims. You are going to have one on biodegradable and compostable plastics. So I think it's not each one of these legislations individually that the companies struggle coping with. I think what the industry in general is struggling is coping with all of them together, more or less at the same time. not to mention other regulations that have been mentioned by Ines, like corporate social responsibility reporting and other corporate issues that have to be done, or maybe others that will come, like the revision of REACH and the CLP that's also emerging. I don't think it's one by one that is problematic. I think it's the fact that there are many. So most companies face what has been said before. It's just one person dealing with safety issues, quality issues, environmental issues, and trying to decide what comes better first and what comes later. And maybe in this context, marine litter is not the first thing on the table to deal with by companies. So I think the fact that OSPAR and Oceanwise have focused on marine litter also helps us to look twice of what we are doing and what we could do better to ensure that there's less marine litter, plastic marine litter in general, and EPS marine litter in particular.
On that note, we really need to close this round table. I wanted to ask you, I wanted to thank also everyone that's been online. I hear that I haven't been following in detail, of course, but I hear every time we break that the discussion has been very intense and fruitful, and so thank you all also for everyone that was replying back and providing more feedback to who was participating. I really want to see what happened online during the day, and well, I want to thank you all for participating today. Over the next, well, very soon, we will still be uploading the final products of the Oceanwise project. Most of them are already online, but keep checking over the next month for the final projects, and come back to us. Of course, we're closing the project, but we are on top of this issue, and we're carrying on with our work and our representations at both at OSPAR and in the EU technical groups on marine litter and others. And well, of course, the Oceanwise team has people working in the very diversified fields that we showed you today. So reach out to us for continuation of for helping you with taking forward these results. And on that note, I thank you all, and the participants this afternoon, and presenters and the invited guests. Thank you. Special thanks to all of you. And for those of you here in Lisbon, stay for the party. And for those of you online, thank you again, and don't hesitate to come back to us. Thank you.
Thank you so much.
Thank you.